and Communication Technologies in Agriculture, Food and Environment, the HAICTA. Let me extend a warm welcome to you all. This is the 11th HAICTA International Conference, which comprises the main scientific activity of our association. As we all know, during the last decades, the use of information and communication technologies in the agri-food sector has become a critical success factor for achieving sustainable food production and for preserving the natural environment. Technological trends and economic analysis suggest that ICT will continue to be a major driver for innovation in the future. The 11th International Conference of HAICTA aims to bring together professionals, experts, and researchers working on ICT in agriculture, food, and environment in order to discuss innovative solutions in real industry cases and to identify current and future challenges in food supply chain. In this conference, we have 106 communications, participants for 21 countries. I am sure that the conference will result in scientific conclusions of vital importance. Besides the expected scientific outcome, I strongly believe that closer relationships could be developed among HAICTA members and conference participants. Concluding, I would like to thank all the organizers and sponsors, as well as all the people who voluntarily offered their precious time to organize this conference. I wish you a productive and pleasant stay in Karlovy of Samos. Welcome to HAICTA 2024 conference. And now, Professor Giorgos Vlontzos, the president of HAICTA, will continue. Thank you.
Good morning from me. Dear participants, dear friends, welcome to Samos. It is very, very important for us to justify to you why we are here today. As you all know, Samos is the birthplace of a very, very important ancient Greek person. We are talking about Pythagoras. Pythagoras lived in Samos during the 5th century before Christ and died in southern Italy in 496 BC. He is considered as the establisher of the foundations of Greek mathematics. He was also a very important astronomist for his era, and he deployed a very, very important philosophical movement named as Pythagoreans. He used for the first time the word cosmos, meaning in English, universe, but under the dimension and notion of universal order. He also merged mathematics with music, as we know it today, 1 quarter, 2 quarters, 3, 4 quarters, being this very, very important for composers, even nowadays. He merged also mathematics with philosophy. Regarding our science, it is very, very important to share with you that Pythagoras was the first vegetarian on earth, supporting the non-consumption of meat. I would like to share with you some of his philosophical thoughts, being very, very important even nowadays. So some of them are the following. You should avoid the big roads and prefer the narrow ones, because following the narrow ones, you are reaching targets very, very important for everyone. Each man is mortal. Each man is mortal with his fears and immortal with his wills. It is impossible someone to be considered as a free man if he cannot manage his passions. And finally, it is better to remain silent and speak only when you have to say something better than silence. This is a very, very good advice, especially for Greeks, because we are very, very talkative. Following this sustainable philosophical approach, he tried also to be an inventor. During the ancient Greek era, it was a very, very big insult for a man, and even more for a woman, to be drunk, because drunk people lose control. So in order to avoid this, he invented this cup. This cup, even nowadays, it is named as greedy cup or cup of justice. So during feasts, the wine was served in these cups. Inside the cups, there is a ring drawn, meaning that the wine had to be served up to this limit. So I will show you how it was working. So if we add wine up to this level, nothing is happening. Okay, so they had the opportunity to drink it. But if someone wanted to drink too much wine and quite fast, he was trying to fill it up to the top of the cup. So a siphoning effect was taking place and the wine was disappearing from the cup. This was a very, very practical manner to maintain and to avoid binge drinking, as we say it nowadays. Finally, it is my pleasure and honor to welcome as a keynote speaker in this HAICTA conference a very, very important researcher and a good friend of mine, Dr. Samir Mili. Samir Mili is a senior researcher and director of Department of Applied Economic and Geography at the National Research Council of Spain. Samir Mili has participated and coordinated very, very important research, European and national research projects. We are talking about Horizon projects, Prima projects, and today he will deliver a talk entitled Innovation and Digital Transformation in the Agri-Food Sector, What is the Role of the Common Agricultural Policy? Dear Samir, the floor is yours.
Good morning, everybody. First, I would like to thank the organizers, George, for their invitation to participate in this interesting conference in this very beautiful place. My intention in this talk is to give an overview on the role of public policies, and specifically the Common Agriculture Policy, their role in supporting and promoting innovation in the agri-food sector. As you know, the CAP, the Common Agricultural Policy, is the main public policy in agriculture in Europe in terms of budget allocation. It accounts actually currently for about 40% of the total EU budget. So, and also, it has been enacted since now more than 60 years. It has been was been first in the Treaty of Rome in 1957 and officially and formally enforced in 1962. So after all this time, it is reasonable and legitimate to ask the question of what has been its role and its impact on innovation in agriculture and food chains, and what I will try to give an overview on this. Also, when I have been invited and with a suggestion to talk on this topic, I found it interesting choice. Of course, because of its potential interest on the conference as a supplement of the technical aspects that are studies, and I saw the program here, but also because of the scarcity of scholarly studies on studies linking policy interventions to innovation actions in agriculture and food supply chains. So, the plan of the talk will be first the agri-food innovation issues and policy interventions to face the important challenges and market failures in agriculture and food and in innovation markets. Then the CAP structure, design, and objectives, and its role and impacts on innovation. And then the CAP modernization and digital transformation in agriculture, rural areas, and food. So, of course, innovation in the agri-food sector faces huge and unprecedented challenges which require policy intervention. Here, to start, innovation is defined as the evolutionary and or disruptive renewal of markets, products, organization, and processes. So among these challenges, we have the need to increase food security and safety, and with less resources and with more efficiency in the resource use. There is a widespread agreement that by 2050, food production should be increased by about 50% due to population increase and also income increase, mostly in many population segments in emerging countries, what is now called the Global South. Also, of course, all you know, the climate change impacts all time, and increasingly we see the extreme waves of heats, floods, drought, and so on. The biodiversity loss also, of course, biodiversity loss and climate change impact has reduced yields and food production also. Water overconsumption. We have been dealt these days, even here in Samos, there is a crisis in water. And also external shocks, financial shocks, geopolitical conflicts, for example, the war in Ukraine, the conflicts now in the Middle East, and their impact on the disruption of global food chains and international trade. And health crisis also, we had the experience of COVID-19 pandemic and the important consequences of on global supply chains, and on here in Europe the impact has been not very intense, but in the rest of the world there have been many important impacts. Also ensure healthy lifestyle, mainly through healthy diets and green environment with more green infrastructures, less pollution. This is a very high societal demand, especially in the rich countries, for example, Europe. Also problems in the rural areas, challenges with the widening divide, rural-urban divide, in terms of, in economic terms, for example, in terms of incomes, the difference in the gap is increasing, and the technologies, not only digital, but all technology, there is a divide, so there are many challenges. And last not least, the need to increase the competitiveness of agriculture, especially through increasing the total factor productivity. This is an important point because often it is forgotten that without increasing competitiveness and economic growth in agriculture, it will not be possible to achieve other objectives such as environmental sustainability or social sustainability of food production. And this, and the competitiveness, the key driver of competitiveness in agriculture is factor productivity. And in turn, factor productivity also cannot be improved without innovations and technical change in agriculture. So to illustrate better this point, we have this important point. Here we have a representation of the sources of agriculture output growth. We have the total factor productivity here in green, which account currently on average at about 60% of the total value growth in agriculture, much more than 25% in the 60s and in 70s, because increasingly the growth and value creation in agriculture is more productivity driven than resource driven. It is increasingly. And also we have this factor productivity mainly is driven by relocation toward more productive farms, the focus on productive growth within existing farms, and also the issue of entry and exit of farms. Also, we have the other factor, other sources of value growth, the input intensification, irrigation, and extension, area growth. These factors are under much pressure, as you know. So to improve sustainability, the trend is to reduce inputs, pesticides, fertilizers, to reduce the irrigation because also the scarcity of water, and also there is very, all over the world many constraints on enlarging land, agricultural land. So these are the main source is increasing the factor productivity, and this trend will be more intensified in the future. And here, of course, also we have as a source the terms of trade and policy price effects. Terms of trade, you know, it is, there are here many economists, you know, this is the ratio between the export index and import index, and also with the price effects. So it is a part of value created from international markets. And here we have the policy driver, the role of policies. No? In Europe, mainly the CAP, the which are policies which are key driver for factor productivity. We have research and development policies, policies for enabling environment for innovation and technology adoptions, factor market reforms policies also, and non-farmers employment growth. So these are policy very important and determinant to factor productivity. Now, we come to the central question. Why the role of public policy, for example, and here the CAP, in supporting innovation is important, is crucial. So it is very legitimate and important question because the answer is to justify the intervention of the public administration and the in innovation. This role is crucial. This is mainly because the level of innovation often is suboptimal. And this suboptimality is due to the existence of what we call market failures. Economists are very familiar with this terminology. And I give some examples. Market failure occur when, for example, we have a situation of underinvestment in one field, here in innovation. And this underinvestment may happen, for example, when innovators cannot benefit from all, take all the benefits from their invention, because, for example, other agents, competitors, consumers, other profit from their investment in innovation without participating in costs. So there is no incentive. On the contrary, they are discouraged to innovate, and we have an underinvestment situation with respect to what is optimum. Also, it happens when negative externalities are produced through innovation processes, new technology, and so on. For example, when there are innovations that can generate biodiversity loss, health risk, even ethical risk. So when we have negative externalities, also we have market failures. And this is also because these negative externality, because usually private company, private party mostly invest in economic-driven innovation, while public administration and many times has other objective, broader, for example, sustainable development and also societal concerns. Even, let's say, increasingly, enterprises also invest in sustainability and social because there is increasing pressure to them. But the standard models is that they invest in profit maximizing activities, and the public, the government support other kind broader goals in innovation. Also, market failures can happen because innovation activity are risky, because not all the projects, as you know, of innovation succeed. So here, very simple economic model to illustrate market failure situation. The idea here is that when, for example, we have an investment in private innovation goal, the private optimum and the social optimum don't coincide, because marginal costs are not the same. Because when we have externalities, the social marginal cost, it is the private marginal cost more the cost of externalities. So the area in between is the market failure. It's very simple. Economists knows very well this kind, and this applied also in food security, in food safety, and environment. But this illustrates the situation of formally the situation of market failure to understand. So if there is no externality, there should be a coincidence between the two curves and the market equilibriums. What happen when marginal cost equals marginal benefit, of course. So in these situations, it is interesting to think in terms of two kinds of costs: the impact costs and the mitigation costs. So when we have externalities, here, for example, in innovation, here we have the impact cost of an externality, and which has total, what is the private and public cost on a negative innovation, for example, risk on health. And on the other side, we have the mitigation cost, which is private and public cost to mitigate the effect of this externality. And the T curve is the total curve. What's happened in practice is that in practice it is not possible to eliminate totally the impacts of externalities. So what happens in policy terms is to identify to make trade-offs between two kinds of costs and to achieve an optimum. And this optimum is the point that minimizes both costs, point F here in the curve. And in practice, when in policy making, the process is to identify an optimum of innovation, in this case, social optimator, and then to formulate public and private strategy to reach this optimum. So, sorry. I said before that innovation is very risky and many projects fail. Here we have stylized representation of different errors leading to failure in innovation projects. Mainly, we have three kinds of errors: planning and design errors, implementation errors, market orientation errors. The last type of error, market orientation, are very important, especially in agriculture and food industry, because, as you know, the food industry and agriculture is formed by more than 90% of small and or very small enterprises. So there is a lack on market orientation, which comes from good knowledge of the consumer studies and the studies of markets. So here it's an important aspect in agriculture. Of course, these errors have many causes, which can be general, specific, internal, external, latent also, not so visible. Let's see a representation of an innovation process to show how dynamic and circular and can be risky also process. And also to illustrate the role of policy in these in innovation processes. We have intervenants, developer, supporter, user of innovation, then different stages, the initiation phase, implementation, dissemination, and in all these, for example, in initiation phase, knowledge exchange, creating awareness, operationalization, then advice, capacity building, support and access to sources, and in dissemination, applying innovation, and so on. These activities are highly policy-driven. Here we have specifically representation of the agricultural innovation system in the EU, and how it is policy-driven. It is sort of square. You have government, business, academia, and social society. The center of the system are farmers, of course, in connection with other stages of the supply chain, with the different agents that intervene, banks, accountants, NGO, media, and so on. And we have major policy areas here, for example, in extension, education, and research. It's area which are highly supported by policy. In Europe, there is also the ACIS, the Agriculture Knowledge and Innovation System. I will talk about it later, which is an important structure and important tool for promoting innovation in European agriculture. This system, this innovation system, should respond to the different different opportunity that happen along the food chain. We see that many innovation opportunities emerge in many areas at different levels of the food chain. For example, the area of environment, which is one of the biggest one, and it affects production system, processing, storage, retail, preparation of food, the area of safety, food safety, including, in addition, organoleptic impact, then an area of nutrition. The final objective of all these innovation is, of course, the health and the well-being of the consumers. So here we have some selected area where there are policy focus on innovation and with particular exposure to research, development, and innovation. For example, in the production area, in production we have digital technology for smart production, increasing focus on this aspect. In processing, innovative processing technologies, and also the packaging area, also very important. That is, this area have big exposure to innovation activities. And there is also a cross-cutting and horizontal objective related to integration between different stages of the food chain, mainly through data generation, data exchange, but also it can deal with organizational innovation, not only technological. For example, better organization of the food chain, the area of contracts, initiative to reduce transaction costs, and so on. Now, in terms of funding, I talk about money. Europe has two means to fund agri-food innovation. First, the common agricultural policy through its financial instruments. Mainly, innovation is in the second pillar of the CAP, not in because the first, which is the biggest one, is about direct payments, market measures. But also we have many programs, European programs, that are not specialized on agriculture, but they partially partially dedicated to agriculture. The most important of these second group of program is the European Research Program, Horizon, now it is Horizon Europe. In this program, Horizon Europe allocate around 9 billion euro to research, development and innovation, so only on the agricultural sector, which represent about 9%, 9.5% of the total budget of the Horizon program. We have also the European Agriculture Fund for Rural Development, the European Regional Development Fund, the European Social Fund, the LIFE program for biodiversity. All Stars is, maybe you know it, is a program, a European program for innovation in SMEs, small and medium enterprises. It is a funding program, but also agri-foods SMEs can participate. We have also as a funding source the European Investment Bank, and another program, not very big, small, the COSME. It's mainly an innovation in international markets, so for internationalization of SMEs especially. So this is mostly the main sources of innovation funding in at European level, but the most important two programs by difference are the CAP and the Horizon Europe Research Program. Here we have distribution of the CAP budget. We have the first pillar, which is 3 quarters, 75% of the total budget, with market measure and direct payment. Almost no innovation funding in this part. And the measure for innovation and the knowledge sharing is in the second pillar, and it is a very small area. In the last CAP, 24-22, in average, it has been about, it had accounted for 1.6, 1.7% of the total budget of the EU. So it's quite low. Well, quite low or not low. Because when we compare it with other sectors, and also when we take into consideration the needs for those reasons, the share is quite low. So in the new CAP, this is a distribution in the new CAP, 23-27. The percentage has not increased in terms of in absolute terms, but what has changed in the new CAP is the focus. With the same amount of budget, the focus has moved toward new technology, and we see in more detail a bit later. So no more budget, but there is a change in focus, a change in paradigm. Here, just to see a typical path of CAP expenditures here in 1 year. Here, for example, in 2018, different items, the total budget, the percentage in GDP, the different items, the most important, of course, there is no one for innovation. It's as important. Now here it's barely close to 60 billion in this year. Now the budget, the total budget, it's almost the same in absolute terms. We have in the new CAP a budget around for the 5 years about 310 billions, but for the 5 years. So by years it's 70, so something like that. Has not changed compared than before. This situation of innovation and it's in part due to the architecture and the design of the CAP. If we look at the previous CAP, it's complex because we have the first level of general objectives to have a viable food production system, sustainable management of natural resources and climate action, balanced territorial development. There are the big objectives which are almost the same since the creation of the CAP. And we have a series of specific objectives, for example, to maintain market stability, respond to consumer expectation, also maintain diversity of agriculture. This is in the first pillar. This objective has reached through market measures and direct payments. And also in the other side, it's pillar 2, the promotion of socioeconomic development in rural areas. And in between, there are sort of cross-cutting specific objectives like enhancing farm income, foster innovation, provide environmental public good, and so on. So it's a complicated structure. And when we come to the structure of the system of implementation of innovation and knowledge exchange in the CAP, it's even more complex, as you can see, because we have measures at European level and others at member state or even at region level. Here we have at European level M1, M2 is the real name of the measures, because the measure in the CAP are measure 1, 2, 3. At the European level, we have, for funding, we have the European Agriculture Guarantee Fund and the European Agricultural Fund for Rural Development. This is at European level. So in there are activities such as the food advisory system, the national rural networks, of course, the direct payment. There was a special action in innovation in wine, and at the member state level, we have the ACIS. The ACIS, very, very important, the Agriculture Knowledge and Innovation System at member state, because each member has its own ACIS. And ACIS involve knowledge exchange, advice activities, research, and innovation. One important structure and tool here is the European Innovation Partnership, which is cross-cutting. This structure, maybe you know it, is very important, but mainly its function is to translate research, idea, into innovations, practical innovation on the ground. And this is done through many structures, for example, thematic network, operative groups, multi-actor projects, these kind of structure. But it is in innovation, in the practical aspects of innovation, this is very, very important. And the European Innovation Partnership also is in direct relation with activities within the European Framework Program. Now, how we assess the role of public policy, in this case the CAP, in innovation activities. Of course, this is very, at least not easy question, because the multiplicity of factors, as we have seen, because also the lack of good quality information. There are many studies in evaluation of the CAP, but most of them are dedicated to evaluation the way of the big money is spent, and big money is in Pillar 1, not in Pillar 2, it's not on innovation. So there is a lot, and there are periodic innovations, but on innovation, there is very few. So maybe one of the most suitable and complete frameworks to have an assessment on the role of innovation is this one, based on hackers and others. And the main idea of this framework, to assessment framework, is that innovation is shaped by a series of innovation system functions. And it established 7 functions for this, 7 innovation system functions, F1 till F7. And for each function, there are a series of indicators to quantify, to assess both a quantitative and qualitative indicator. For example, let's say knowledge development is F2 created through research and development essential for innovation, including search, learning, and learning by doing. This is the description of the function. For this, to this function are associated indicators. For example, the number of research and development projects, patents, and investment in research and development. If there is an increase in performance by learning, diversity and quality of knowledge development, innovation process, and also number and types of partners involved. This is an example. For example, the function, the innovation function linked to resource mobilization, function 6. It relates to both financial and human capacity required to innovate, such an investment in research in relation to function 2, because also functions are interrelated. And here also we have a series of indicators like type of resources available, perception of accessibility, degree, the availability of resources, or there is obstacles, evolution and availability of resources, and so on. So the idea is to detail the in a system perspective, the innovation process in various functions, and to establish various criteria, various indicators, and then collecting that data, qualitative and quantitative, to assess these functions. Of course, this framework is especially interesting for ex-ante assessment. For example, when you have a sort of measures, when they're preparing a new policy, new measures, is to use it and have measurement of different criteria to make recommendation maybe for changes. So if we apply this framework to the previous CAP, of course, because the new CAP cannot assess it because it's just starting. So we can do this to the 2014-2022 CAP. So this is a matching exercise. We have match functions, innovation instruments of the policy, the CAP in this case, and the different functions of innovation systems. So we have the different 7 functions and the different concrete measures that are related to the innovation in the CAP to the agricultural sector in Europe. So here are the measures of the Pillar 1. As I said before, almost no impact on innovation, and all the measures related to innovation are in the second pillars. For example, in the Article 15, related to advisory services with measure 2. So this is there are 3 or 4. It is related, this measure, to five functions of the innovation system. Others are, for example, the first one, the knowledge transformation and information action, is Article 14, is almost related to all of them except function 5. So it is a much exercise and allow to visualize the measures and the functions. Example, and then it is a good exercise and allow to make assessment and make a recommendation for improvement or for amendments. Now, in the current CAP, we call it the current new CAP because it's just starting, there is more focus on modernization. As I said before, the budget is almost the same, no significant change, but what has changed is the focus. And the focus in the sense of more modernization through innovation and digitalization and knowledge exchange in agriculture. There's more focus on this activity with the same budget. So here we have the new CAP. It has 10 objectives. One of them explicitly is on knowledge and innovation. The new CAP in the 2 pillars still exists, but there is more integration between the objectives of the 2 pillars. And for this reason, for example, it is presented in this way, in 10 objectives, and it's not as before, Pillar 1 and Pillar 2. And there are many cross-cutting objectives also. So here, this focus is materialized also by the inclusion, because the formal text of the CAP include a cross-cutting objective on innovation and digitalization are key elements of modernization, because as you know, agriculture of the least, or maybe the least digitized sector. But by the way, even also the private investment, I talked before on the public investment, which is limited on the CAP and the Horizon program. But even the totally private investment in innovation on agriculture and food is relatively small. In Europe, in average, private investment on innovation is about 5 billion euro, which is, of course, very far, very low, for example, compared to health sector or digital technology, with about 50 billion euro a year, so 10 times more. So it's a private. So in the new CAP, we have a cross-cutting objective on modernization and digitalization, through digitalization and innovation, and also a specific objective on improving market orientation through innovation and new technology. Before, when I talked on the error on the innovation projects, I stressed on the aspect of market orientation, because in agriculture, everyone knows the importance, but the very structure of the agricultural sector make it difficult to resolve or to improve market orientation issues. So mainly to produce products what is accepted by consumer. It is easy to say, but difficult. And the structure of the sector with very small farming, with the farmer, makes not easy to this situation. And for this reason, in this CAP, there is a specific objective on improving market orientation issues. And that is through innovation. So to dedicate part of budget and innovation into these aspects, both market orientation, national, regional, European, and also international. As you probably know, the new CAP is structured around the strategic plans. This is an innovation even in the structure of the CAP. So each country prepared its own strategic plan. Strategic plan mainly establish the way the country is planning to target the local needs in its agriculture, being in line with European policy, the general CAP objective, and also in line with the European Green Deal. And for agriculture, you know, the European Green Deal has two aspects. It's two important programs: the biodiversity program and also the farm to fork strategy. This is both, because as you know, the European Green Deal is very much bigger. Climate neutrality and so on. It's touch all the sector. So through the CAP strategic plans, also it should be explicit the mention of modernization activities. So activities mainly are digital strategies, advisory aspects, and the AKIS, the agricultural knowledge and innovation system. And also it is here the specific article when it is mentioned. So each strategic plan should contain a description of the strategy of the country on how the country will develop digital technology in agriculture and rural areas, and also how the country will use this innovation. So it is explicit. So it is a part of the change of the focus. Now, the AKIS, which are a sort of combination of organization and flow of knowledge, between different stakeholders, individual, user, institutions, organization. This structure are key in this strategy and change in focus. So here we have the main function within ANAKIS. Each country has its own agriculture and AKIS, and agriculture knowledge innovation system. So, and also in the it exists from since before, but its importance and relevance in the new CAP has increased. And explicitly, for example, in each strategic plan, has to describe to how the contribution of the AKIS will be. So the description of the organizational structure of the different of the AKIS. So we'll go maybe a bit more quickly. Of course, the new digital technology are have an equal impact on agriculture and food chains. Here, a representation of this different kind of classification on impacts: low, medium, and high. I don't get into technology. I'm not expert. Here, I think there are more people expert on this, and some of this technology will be tackled, and there are papers on them. But let's see here, for example, when it's indicated low impact, it is not because it's really low, but mainly because some of these technology have started before, and the major impact has been already implemented. So, but the highest impact can be the IoT, automation, artificial intelligence, of course. The medium impact, blockchain, the navigation systems, virtual reality, and so on. Also, digital technology could be beneficial to all the food chain at all levels: farmers, public authority, consumers, and so on. For example, for a consumer, can help them to have real-time data and improve the way the information on how the products have been produced, which is a claim of the consumer, I think. Also, here in terms of funding, this is the point. This digital transformation is funded, or is projected to be foreseen to be funded through mainly two programs: the Horizon program, with these objectives to develop a digital solution, enabling key challenges in agriculture, increasing effectiveness, and so on. And another program, the Digital Europe program for agriculture. And the main point in this program is to establish the common European agricultural data space. This is in digitalization, maybe. So in this point, in the European digital space, it is establishment mainly to develop data sharing platforms and ecosystem that allow data sharing and interoperability in different application stakeholder in the agriculture sector. This is the main objective of the Common European Agricultural Data Space. Also, we can have benefits to several levels: farmers, private sector, public sector. For example, for policy analysis, the benefit can be as it is a program on improving production of data and data sharing, so can make the analysis of sector easier, and also can make easier the monitoring of the activities. Okay. Now, we should also take into account that, of course, that agriculturalization could have potential negative impacts here, as sort of from take it from a publication, a Greek author. There is some of them. They can be social, ethical, and even political impact, ecological, and cultural. And this, for example, reduction innovation that could reduce biodiversity, loss of traditional crops, because modern technology and traditional crops maybe they do not go in the same direction. So the point here, these are sources of market failures. So when we come back to the other. So when we have negative impacts, so they are sources of negative, of market failure, and all the process we have seen before. So let me now conclude with these key messages that I think deserve to be communicated. First, public policy are crucial to correct market failures and also to provide socially acceptable, desirable level of innovation. Also, innovation is a driving force, the most important, behind digital transformation and factor productivity, and in consequence the competitiveness. Also, there is a need to align budgets with need. We have talked about the limited share of budget devoted to innovation, considering the challenging the agriculture and food sector are facing. Also, the need to better tailored instruments. We have seen the complexity, the high complexity of these measures. Also, the CAP should better address risk aversion to innovation, fragmentation, and the limited uptake of technology, especially in rural areas. And finally, maybe also a need for different focus. And the focus, the system focus, the food system focus. So maybe there is a need of paradigm change and of thinking. So to move from compartment thinking to system thinking. And maybe this is not very far from what Pythagoras said. And thank you very much. And sorry maybe for the time.
It's okay. Thank you very much, Samir, for this very, very interesting talk. I will give the opportunity to the participants now to ask any questions. Yes? Yes. Just a moment.
Well, first of all, you don't need to one moment. One moment. Time. You were perfectly on time. You don't need to feel sorry. Thanks for this very comprehensive. I would like to ask you a question, and don't take me wrong, on behalf of farmers. Last year and early this year, there was the first ever pan-European farmers demonstration in all over Europe. How much of this event was considered, was heard, and will be implemented in the new decision-making by the Commission of Agriculture, DG Agriculture, etc.? Thank you.
Thank you. It is an important question, because these demonstrations, the tractors, it was in all over Europe, in Greece, in Spain, in France, and it has causes and it also has consequences. As far I know, there has been changes that in the CAP since then, and the changes are mostly focused on on two aspects. They're trying to the Commission to reduce bureaucracy, because that is the burden of bureaucracy really is very, very high, and it's very important. And the other one, what is a demand of farmer, is to reduce also the burden of ecological norms. And now, formally, in both lines, there have been changes. and adopted in the European Council and now the implementation. You know, always it's not so easy. So there are some parts because part of the implementation depends on the country. So and this is capacity. So it is an even impact on the situation. No, in this. I don't honestly know how this have been implemented. This change in Greece, but for example, in Germany, France. At least some of them have been implemented. But it's important because they touch two important weaknesses, two important points, which is not good, let's say, what is the excess of bureaucracy and this some who can say that some ecological radicalism, let's say, some say, but maybe somebody did not agree. This thing.
Okay. Thank you very much. Any other questions? Okay. I have one, Samir. Recently, Mario Draghi publicized some thoughts about the future of Europe, and he was deeply concerned about Europe that is lagging behind in research and innovation activities and projects. Part of it, of course, is related to agriculture. Mario Draghi asked for more money being invested in research and innovation, especially when we're talking about agriculture. Is it only an issue of lack of financial resources, or in this case, things are more complicated, according to your opinion?
I think things are more complicated. It's not always a matter of budget. There is, I think in my talk, maybe I'm not very clear. There are two aspects. The aspect of budget and also the aspect of organization. We have seen the complexity of the organization. So this need to be somehow managed and changed. On the budget, I think the report, and the report of Mario Draghi report, it's a huge, like a Marshall Plan, no, something industrial, which, of course, deserve to be read, to be considered, because in the budget, in innovation and digitalization, Europe lags much behind other big players like the US or China. So there is an issue on budget. But there is also an issue on organization. So it's not only a matter of budget.
Thank you. Thank you very much. Any other questions? Okay. Thank you very much. Thank you very much, Samir, for your talk. And now we are proceeding to the next session.
second session of the day, maybe the first after the plenary speaking. It's called Livestock and Aquatic Production Systems. And I would like to invite the first speaker, the first presentation by Mrs. Maria Alvanou from University of Western Macedonia.
Now it's fine. Okay. So good morning. I'm going to present you our work we did regarding an evaluation of an easy handling and low-cost cages for a species, a freshwater crayfish species, Podostaxus leptodactylus. So as you can see in the photo, since the previous HAICTA, not much has changed, as we conducted a lot of experiments regarding this species, as it's my PhD defense. So what have we done since today? We did some experiments on the optimal diet of this species. We tried to find the optimal amount of protein and lipid levels for diets of this species. We did some genetics regarding the population, and also we aligned the whole mitogenome of the species. Also, we conducted some experiments regarding the main diseases of the species, of the Podostaxus leptodactylus, and we found for the first time in Greece the Aphanomyces stasi. It's a pathogen which causes the crayfish plague disease. And also, we conducted some experiment regarding the artificial hatching of embryos of the species under laboratory conditions. And after all these works, we tried to find our next step, which is the development of an aquaculture protocol. And a really important thing under this perspective is to find the optimal density of the individuals under laboratory conditions in these cages. So what we did, we calculated the surface occupied by the animal as an ellipsoid shape, let's say. So we took the maximum weight from the walking legs, as you can see in the fourth pair. I don't know if you can. Yeah. Here. So this is the maximal width and the maximal length. So we calculate with this formula the optimal, let's say, density, because this species has high cannibalistic behavior. And it's really important to identify the correct, let's say, density in order to have, not to hampering the growth of the species. Yes. So this is our methodology. We collected 300 individuals from wild populations, and we divide them according to their developmental stage into groups. And then we gave them the two different diets in each developmental stage. Again, one which had only fish meal, and the other one which had a partial substitution of insect meal, of Hermetia illucens. And why did we choose the insect meal substitution? Because we noticed from our previous experiments, that it has in the individual that was given a diet with insect meal that has higher survival rates, and it boosted their immune system. So we wanted to continue under this direction in order to have the optimal density and to give them a diet with insect meal in order to enhance even more their survival rate. And also because it's also observed in previous experiments in other aquatic species that insect meals has an effect in survival rate. So what we did in order to save some space, because as you probably don't know, this species is benthic species, so it lives only on the surface of the bottom, let's say, of the water tank or in the lakes. So what we did, we ordered some structures like that, and the advantage of these structures is that can be folded into cylindrical shape. And we can add some crayfish inside. This is the cages. And the advantage of these cages is that the individuals do not only remain on the bottom of the cage, let's say, but they also can climb, and you can save space by this rectangular type of cage. And here are some real photos. As you can see here, in the second photo. Oh. Yeah. As you can see here, there are some crayfish individuals inside, and then we transfer them into the water tanks. So here it's our experimental setup. As you can see and can imagine, it was a really a lot of work that had to be done because we had to change the water, and we had to feed them every day, twice a day. And we have to measure, of course, temperature, water quality, etc. And here, the reason why I added this photo is because here, for example, you can see the crayfish that is on the top, let's say, of the cage, and not only on the bottom. So from our results, occurred that the main result was that, as we can observe in the first developmental stage, in the small crayfish, we observed that the survival rate was pretty much the same in two different diets, in comparison with the bigger developmental stage, where the crayfish with a fish meal had better survival rate, while the SDR rates was lowest generally, because the species has a low growth rate in general. But we observed that it had better SDR rates in the diets with insect meal. So what is our next step, and why did we use these cages? Actually, our final step is to develop, after all this work we have done regarding also the other experiments, is to transfer these cages, as they are easy handled, low cost, and you can save some space. We want to transfer them to release them in the field, in lakes, for example, because this species has both ecosystem value, because it operates as ecosystem scavenger, but it also possesses high significant, high economic value, as it is export oriented, and it gives an extra income to the local fishermen of the region. So, in conclusion, this was a really difficult experiment, because we had a lot of work, and we had to do with this animal, which is really difficult to handle, and the individuals were a lot. So the advantage of these cages, let's say, these plastic cages, is that they have reduced cost in comparison with other materials and practices. It's easy and user-friendly handling. We can transfer them easily in field release. You can also connect them, the cages between them, and you can have a big row of cages in the environment, in the field. And also, it's you can save space, because the animal, as a benthic species, they can not only remain in the bottom, but they can go and climb on the top, and that's the reason why you can save space, let's say, from the and find the optimal density. So yes, pretty much that was that. Thank you so much for your attention.
Thank you, Maria, for being on time. I think there is time for one question, at least, if somebody would like to ask anything. Okay, if not, I just would like to ask you, Maria, to mention the problem, only a few words, 1 minute, the problem of mortalities that are, and how your work is connected to the mortalities that are observed during the last years in lakes.
Okay, yes. Thanks for your question. Yes, during the last year, let's say, we observed an epidemic in crayfish species in the lakes, caused by the Aphanomyces astasi, which is It's an oomycetes and devastated the population, so it has there is a scope, there is a perspective for the restocking efforts that we want to make in order to save the populations and to retain the population in order to give.
Thank you. Thank you very much. To enhance them, yes. Thank you very much.
Thanks.
Thank you again on being on time. And I would like to invite the next presentation, the next presenter, who is Mr. Yannis Manetakis from Foundation for Research and Technology from Greece here, who is going to present building a global aquatic resources knowledge base for fisheries.
Thank you very much. Good morning. My name is Yannis Margiatakis. I'm a research and development engineer from the Foundation of Research and Technology. We are located on the southern part of Greece, in Crete. So I will try to spend my 10 minutes starting by an introduction of what we are doing in this paper, and then moving on to the motivation and basically some background information, and then I will give you more information about the knowledge base and the construction process. So these are a couple of screenshots that I found a few days ago, and the first one informs us that by 2048, all our seafood will go extinct if we don't change something. And the other one describes the consequences of overfishing into various species. So the question is, how do this information emerge? Well, one answer is through fisheries management. So fisheries management analyzes various data in order to make sustainable use of resources, to support the conservation of marine ecosystems, the regulation of fishing practices, and many more, as you can see here. So it's very important that all the information that fisheries management assesses has to be accurate and complete. One such indicative information is species. So how do we identify species? Well, this depends on who you ask. For example, usually people use common names for identifying species. So if we ask a chef, for example, she will tell us that this is a red mullet. Now, the problem with common names is that there are many different common names in many different languages, and even more, there are many different common names for the same language. Of course, we also have the scientific names that the scientific community usually uses, but even more, there are many public databases and knowledge bases out there that use different codes for identifying the same species. So we have a much diversity over there. So in order to cope with these problems, we have implemented a process that relies on semantic web technologies. And the way we do it is that we collect information from different data sources. We describe them using a single model, so we would like to have a unified view for all those collected data sources, and we transform them into a single knowledge base. So it's like connecting the different pieces in a puzzle. This is called semantic data integration. And what the semantic data integration offers is that it offers us a holistic view of our resources, of our heterogeneous resources. So it's like having a 360 view of our data. And we have many benefits if we do it. We have complex query answering and many, many different things. Now, the key element to support this is that we have to rely on a single model. Remember, we have different data sources, each one described with its own schema, its own structure. So we want just a single data model. In our case, we're using an ontology, which is called Marine TLO. It is an ontology for the marine domain mainly, but of course there are many, many alternatives. So let's see an example about species. So in the context of species, we used 4 different data sources. These are widely used and widely known. The first one is FAO ASFI's list of species, the World Register of Marine Species, FishBase, and ITIS. By the time of preparing those slides, we have also included 2 more data sources, GBIF and IUCN already list of threatened species, so I included them here as well. They are not documented in the paper because we have not included them in the paper when we were writing that. And you can see also the different information that all these data sources have to share. So let's see the process. The process starts by collecting data from those data sources. And we do it using different means of collecting the data sources and different structures and formats. So for example, for collecting information from FAO ASFI's list, we download the resources in CSV format. While for worms and FishBase, for example, we use the programmatic API and we collect data in JSON format. So we have heterogeneity also in formats that we download the data. And for IDs, we're using an SQL database. So after collecting all those data sources, they pass a series of transformations and normalizations, so they are described with respect to the ontology that we are using. So at that point, instead of having different data sources, we have a single knowledge graph. So we have all the different data sources connected together. And this is how it looks like. It's only a small sample of what we have, but you can see that for a single species, we have all the different identifiers. You can see them on your left, the different names, and the taxonomic information. Of course, we have many more. We have distribution information, ecological information, and many, many other things. The idea here is that in these rectangles, you can see the different colors that show which data source is contributing what type of information. And you can see that all of them share the scientific name in common, which is the glue for collecting all those pieces together. And the idea is that now you can get any of this information, and the other ones that I do not show here, using any of these things. So for example, I can search using the AFI ID of a species and get the taxonomic information, or the common name and get the ASPIS ID. And here, for example, you can see how we can browse all these things. The first thing is purely technical. It is a Sparkle endpoint, as we call it. But this is what supports complex query answering. For example, what you cannot see over there, because it's a Sparkle query, we ask for the identifiers with respect to AFIA and fish base and the scientific name of a species that is known as a red mullet. This is a type of question that in order to answer it, you have to combine information from different data sources. And here you can do it only using the single knowledge graph. And on the lower part, you can see a dedicated web application that you have built on top of that, and you can use it. I have some links at the end of my presentation. Now, apart from species, we did the same thing with other aspects, so water areas and fishing gears. And you can see the actual numbers as regards the total number of species, water areas, and fishing gears that we have. Now, if you ask why species, water areas, and fishing gears only, well, that was the initial requirement for harmonizing the resources in the global record of stocks and fisheries, which is a joint effort with other organizations like the Food and Agricultural Organization of the United Nations, the Sustainable Fisheries Partnership, and many more. To close, what we have presented is not only a knowledge base, a global aquatic resources knowledge base, but also the construction to use it. It can be used as a reference for harmonizing resources for fisheries management and not only. It is fully configurable and can be applied also in other aspects. So although we focus only on species and water areas, it can be applied with other aspects, so countries, management entities, whatever you can think of. Now, in future, we plan to add more data sources in this, so it's totally, it's expanding gradually. And as you have seen, we have also included 2 new data sources by the time of writing the paper. And we want to focus more on the automation of the construction process, to do it in an automatic manner when the data sources have refreshed contents. This work has received funding from 2 Horizon Europe projects, the first one being Blue Cloud 2026 and Veryfish. And before closing, I have to mention that this is a joint activity, of course. It was carried out by me and my colleague Yannis Gizikas from Fourth, but also from colleagues from the Food and Agriculture Organization of the United Nations, namely Aureliano Gentile, Anton Ellerbrink, and Mark Taconet. So thank you very much. This is the URL for the web application if anybody wants to use it. Thank you. I hope I was on time.
Yes, thank you very much. Firstly, for being on time, and secondly, of course, for the very interesting presentation that I liked very much because this is in part of my field of expertise. But firstly, I would like to ask for any question. We have time. If is there any question? Yes, Dr. Lundries.
Could you, please?
Thank you, Yanni, for this very, very interesting presentation. We know that data management and data sharing is a very, very challenging issue in almost in every research project. So how much feasible is your platform to be shared in other widely recognized platforms related to data management and already being utilized in relative horizon projects?
Mm-hmm. Yes, good question. In fact, what we have, our technology, what we are using in order to build this knowledge base relies on a mapping specification language, as we call it, and a series of tools and services that do all these transformations. So they are domain-independent technologies and mapping specifications, which means that they can be applied to different disciplines. Apart from that, we have also APIs that are well documented, and they can be plugged into different platforms and different services and tools. So it's totally configurable. In fact, we are applying this not only for the biodiverse domain, but also for the cultural domain. So it's totally feasible to do anything.
Thank you, Yanni. If there is there any question, any more? Just a very small one, because I like very much your work. Maybe consider in the future to update your platform with CABI as well, which is for the invasive species. It's a similar like fish base, like maybe the IUCN at least, but it's focused only on the invasive species. And invasive species for fisheries are a big problem, as you probably know better than me, in particular in Crete, a lot of them.
Thank you for the information. Yes, that would be useful.
Thank you. So we can proceed to the next presentation with entitled iRunMon Real-Time Ruminant Monitor, which is going to be presented by Mr. Pedro Gonçalves from Instituto de Telecomunicações from Portugal.
Thank you. Good morning. My name is Pedro Gonçalves. I came here to present a real-time ruminant monitor platform that we have been developing with a Portuguese company named Wiseware. Our goal was to create an open platform that could monitor animal behavior in their life and to analyze data to create some alarming messages when something goes wrong, and to transfer the data to a central cloud hosted application in order to create some behavior models. The created platform includes a collar, a sensing collar that analyzes animal behavior. The collar is operated by a mobile device, an Android device. It sends data to an aggregating gateway. The gateway is also enabled to receive video information monitoring the animals and sends the data to a cloud application. The collars sensor data, they include an accelerometer that continually monitors animal behavior. It has a thermometer and it timestamps each sample. The collar is operating using an NFC button, contacting technology, something like the electronic payment, contactless payment, or through an app, and it receives as well some operating commands through the gateway. Data information is performed using Bluetooth energy communication, something that is nowadays available in any Android device. The gateway aggregates the information from the several collars, it integrates it with a data server, and it operates an edge device. It can perform some data analysis, it can create some alarms, and it sends it to the human responsible. So the system includes some monitoring modes. It can monitor continuously monitoring the animals. It was thought to perform offline monitoring. A second operating mode, a special learning mode that can monitor animals and allow to annotate the data information. And a special learning where the monitoring data can be enabled with some video recording to perform learning applications. So I will show you some examples of the learning mode applications that we used in the past. The system includes a web app that can be used within an Android device, and it allows to annotate the animal behavior. So since the Android device can directly communicate with the collar device, it allows to annotate the monitoring data stream, and it allows to perform a next learning operation. So you can see in the right top of the slide some data, some monitoring data. It just includes the timestamp and the free values of the accelerometer. And after the annotation with the known behaviors of the animals, we can implement a learning process that allows us to classify the animal behavior. The second operating mode allows to offline monitoring animals. So it was thought to perform the continuous monitoring because the system, the collar contains an internal memory, and it allows to perform a continuous monitoring. So like that, we can detect unexpected situations and generate some alarms, or we can classify the animal behavior through all the day. We applied it as well to calculate the energy expenditure. We know that the energy expenditure depends on animal activity and on the behavior. So we implemented some energy expenditure calculator through the whole day. A final learning mode, a special learning mode, allows us to integrate video images and monitoring data. And we used to implement some ruminant bird detection. We applied it for the sheep lambing, and we know that about 5% of the birds present some kind of problem. As with the humans, with no help, some of the lambs die. Some of them result in injuries, something like dystocia, that's a disease for the newborns, and the vaginal prolapses from the mothers. So, you know, human supervision allows nursing help, but that's very costly, and we never know when the lambing occurs. So, we are lucky because most of the symptoms of the birth to happen depend on animal dynamics, and the collar allows to monitor it. We implemented some trial. We used video to record sheep lambing, and we used the collar telemetry data to monitor animal dynamics. So we repeated the trial at the bottom in Portugal, in a school in Viseu, and the second one within a collaboration with NIBU. We left them the collars monitoring the sheep, and we were able to monitor 61 sheep that they had 144 lambs. Some of them they had single, some of two lambs, and there was some of them with 3 lambs per sheep. those are very preliminary results, but on the left you can see a confusion matrix. That's something that represents the difference between what was what happened in the vertical and what was detected in each of the situations. And luckily, you can see that there is a huge amount of correct detected cases. That's what represents the confusion matrix. Obviously, there are a lot of false positives and false negatives, and we take the opportunity to implement some kind of filtering. Something like it was filtered based on if we know that we are 5 hours before the landing, we cannot receive a provision that we are 6 hours away from the landing. And if we were 5 hours from the landing event, if we receive a provision of 3 hours, that's not something reasonable. So we decided to filter it. You can see we keep receiving some false positives and false negatives. So that's an ongoing work, and we have to improve it. As I mentioned, we did it with the goats at INIAV, some public research institute in agronomy at the south of Portugal. And we created a data set as well. We implemented the exactly same process. We recorded the goats. We gathered the dynamics of the animal through the color accelerometry, and we determined when exactly the kidding occurred. So that's my presentation. Thank you for your attention.
Thank you very much for the interesting presentation. Let me ask first the floor if there is any question from anybody. No, Alex.
Hello. My name is Alex Theodoridis. I'm a professor at the School of Veterinary Medicine. I deal mainly with economics of livestock production.
Mm-hmm.
I just would like to ask how user-friendly is this device and this application for the farmers? I assume that this application mainly supports farmers that rear their animals under extensive systems, that the animals are grazing.
Extensive and semi-extensive.
And semi-extensive, yeah,
Yes.
okay. How user-friendly is this application? I mean, can they interpret these results that they receive on their phone by their own, or do they need the support of a technician that will give them this information at the end, you know?
This is an ongoing work. We can create some information like that, but we are not sure enough to say you will have a lamb within 3 hours. We still have yet a lot of false positives that they are not acceptable. In terms of user friendliness, we have a collar that is operated through an Android phone with NFC, near field contact. We can turn it on, turn it off. We can monitor it or configure it. Within the gateway, there is a direct communication. We are able to send commands and to change the operating mode of the collars through the internet, and we are able to receive the information and the events, the alarms within the system. It is not completely user-friendly because of that part of the work that was not completed yet.
Thank you. Okay, Aphrodite, yes, please.
Yes, hello. May I ask something, please, about the communication protocol you use in order to take the data central to the gateway? Do you use the LoRa system?
No. We use Bluetooth low energy. Bluetooth that we use to communicate. There is a version low energy, not Bluetooth classic, that we usually use to hear music, but BLE, Bluetooth low energy, that allows us to communicate in a energy saving mode. So the gateway, as soon as it receives the radio coverage of the caller, it establishes a connection, it takes the data from the caller, it gathers the data from all the callers existing in the...
Yes, but in order to be more concrete in my question, what is the distance between the gateway or the antenna that receives the signal from the animal that is tracked?
It depends if we are in open space, something like 10, 15 meters. If we are within a cage, a barn with a lot of metallic cages, it reduces the coverage. But our system implements an opportunistic communication scheme, because if you don't have any radio coverage, the device keeps the information within its internal memory. So as soon as it gets the radio coverage again, it reestablishes the communication and transfers the data.
Okay, thank you very much.
Thank you very much. If there is if there's not any other question, thank you. I think we can proceed to the next presentation now, which is going to be held by Dr. Professor Soteria Vouraki from University of Ioannina, entitled Decision Support Tool to Evaluate Economic Performance of Small Ruminant Farms. And it's going to be, okay, yes, we can see you.
Good morning to all. Thank you, Professor Yansis, for the introduction. Glad to be with all of you and presenting here this decision support tool to evaluate the economic performance of small ruminant farms. It's a collaborative work between the Aristotle University of Thessaloniki and the Proud Farm group of farmers within the project Proud Farm. So dairy sheep and goat farming, we know that requires specific skills and comprehensive planning of daily activities in order to ensure the profitability of the farms and their sustainability. However, we see that in practice, many farms are characterized by low animal productivity and also high production costs, especially for the nutritional management of the animals, but nowadays for other issues as well, such as energy or veterinarian costs. And at the same time, they have low farm income. This low farm income is mostly related to the low animal productivity, which is an effect of the lack of genetic improvement mostly in sheep and goat farms, but it also relates to animal health and welfare issues. And in all cases that we see that farmers are reluctant to adopt new innovation and new technology and undertake professional management of their farms. So we believe that the solution lies on the adoption of digital technologies and decision support tools that could help farmers manage their farms more efficiently. With this in mind, our objective was to develop a farmer-friendly web-based application to help farmers manage the finances of their farms by projecting daily income over feed cost. So for this purpose, initially, we started by setting up the input parameters that we would need for such an application. These include the number of milked animals and also the daily milk yield at flock level, as well as the daily feeding allowances to each animal category, depending on their production and their physiological states, concerning the amounts of lucerne hay, straw, silage, and concentrates, as well as any other feedstuff that is potentially used in a sheep and goat farm. There is this possibility to include it. And on the other hand, we include the price of milk salt and the cost of each individual feedstuff. We also believe that it is important to include default values in some cases and hypothetical boundaries for each of the input parameters that are requested to minimize the possibility of potential errors. These data are provided through the Laboratory of Animal Husbandry of the School of the Veterinary Medicine in the Aristotle University of Thessaloniki through previous projects. So based on these data, we created an algorithm, which is pretty simple. So on the one hand, we have the milk production and the price of milk sold, and based on this, we calculate the daily income from milk. And on the other hand, we have the nutritional management applied by the farmers, the cost of these feedstuffs, and we calculate the feeding cost in order to eventually project and provide to farmers their daily income over feed cost. This algorithm was then used as a backend for the creation of a web application. I will not go into much details about its architecture, which is not my field of expertise, but it has been created in a way that it supports efficient data management and processing of all information in real time. So data are inputted into designated web forms, and they are validated using the default values and hypothetical boundaries that we previously discussed about. And they are stored safely on cloud, protected through authentication and authorization processes that take place. So with all of this, we created the Proud Farm app, as it is called. Users can have access to the web page through the Proud Farm Incubator link, which we can see in the slide, which also provides information for best practices that could be used by sheep and goat farmers, and then give us access to the app, which calculates the income over feed cost as well. So we can see that users can log in using their individual email and password after they have created their account by signing up. So once we have logged in, we move to the data input page, where users are initially required to input data regarding all the parameters that we discussed. So the number of their milked ewes or goats, the total daily milk production at flock level as it is in the cooling tank, so it's easy for them to know this number and input it in the page here. And they also need to include the total amount of concentrates, straw, hay, and or silage, if used, or any other feedstuffs that they provide in each animal category in total per day on a daily basis. And by saving this information, they are also provided immediately with the results, which include the daily income from milk, the feeding costs, and then the total profit, the daily profit, and the respective profit per milked animal. Users can also export all this information to PDF formats, both the parameters and the results, by using the export to PDF option that we can see here on the slide. And here we can see a screenshot of a daily PDF report that has been produced, including both all the input parameters that the farmer used and the results that were produced. What is also important, and we believe that actually can help farmers make comparisons, is to visualize graphically the financial outputs, which can be done by using the profit calculator history, which is also available in the app. So for example, we can see the feeding costs per day and the daily income from milk, the profit in total or per milked animal. And we can see that there may be changes in some days, and by these farmers can understand some issues regarding the management and make relative comparisons. And finally, only the administrator has access to the user management page, where he can edit information if needed regarding the accounts or delete accounts. So to conclude, we created a farmer-friendly, we believe, web application which projects the daily income over feed cost. We believe that this app can help farmers monitor the economic performance of their farms more efficiently and help them make decisions towards higher efficiency and profitability. Our next steps are to include other farm operating costs as well, aside the nutritional management costs, to calculate the net income. Finally, I would like to acknowledge that this work is funded by the Measure 16 cooperation, co-financed by the European Union and national Greek budgets under the project Proud Farm. And thank you all for your attention.
Thank you very much, Professor Vouraki, Soteria. Thank you very much. I think we have time. Thank you also for being on time. I think we have time for one question, at least. Okay, let me make a question if I'm allowed. Because I see it's this very interesting platform. May I ask, maybe as a next step, because the data are already more or less inserted in your platform, could it be also utilized for environmental footprint of the products? Because you have inputs, you have outputs, maybe, of course, some modifications are needed, but it could be very, as a second, of course, the farmers do not care so much so far, but in the future, maybe they'll be obligated.
Indeed, this aspect that you mentioned is very important in terms of environmental awareness and calculating this environmental footprint, and all farms will be required to do this. They are actually, and it will be more important in the coming years. There are other apps that we know and at European level which help farmers monitor such practices through European projects as well. Well, initially, our concept for this app was to be specific on the economic aspects and be very, very simple, as you can see, including only the costs related to feedstuffs and the income from milk. Yes, we believe it's important to include more information, more input parameters and cost-related ones, as also it would be to include environmental parameters. But we believe this should be done step by step because we have worked in other apps as well, which are much more inclusive and include much more information. And we find that farmers are reluctant to use a tool which includes more information, more data input from their side. So yes, we want to do it, but we need to find, I believe, a way so that we do not include so much input parameters for the farmers, but we can actually give them an output which also includes this environmental efficiency performance data.
Thank you very much. Thank you for attending via Zoom. So, if there is not any other question, we can proceed to the next presentation, which is entitled Investigation of Gene Polymorphisms in FGF and STAT5A genes in the Greek red cow breed, and will be presented by Mrs. Tsokanda from Aristotle University of Thessaloniki.
Good morning. My name is Tsokanda Paraskevy Eleni, and our paper is about investigation of gene polymorphisms in FGF2 and STAT5A genes in the Greek red cow breed. During the last years, there has been growing scientific interest in the use of genomic information as an additional tool in conventional dairy cows breeding scenes. Identifying gene polymorphisms at quantitative trait loci that may be associated with economically important trait is the key in this effort. Polymorphisms can affect various production traits that are very important, like reproduction traits. In this study, we investigated the presence of two single nucleotide polymorphisms, SNPs in the FGF2 and STAT5A genes in the Greek red cow breed. Firstly, FGF2 gene is located on chromosome 6 in bovine and has an important role in tissue development, homeostasis, regulates the epithelial expansion in the mammary gland, and regulates the expression of interferon T, a key member of signal transduction pathway in milk production. The SNP is 11646, where adenine has been replaced from guanine in intron 1 at the FGF2 gene. The second gene is STAT5A, that is located on chromosome 19 in bovine, and in dairy cattle participates in milk production. It also affects the success of fertilization and fetal survivor. The SNP is 12195, where ketosine has been replaced in exon 8 from guanine, Excuse me. The aim of the present study was to establish FGF2 and STAT58 genes, allele and genotypes frequencies in the Greek red cows. We have to know that no similar studies regarding these genes have been reported in this breed raised in Greece. So, the Greek red cow breed is one of the cattle breeds in Greece. This breed is connected to the Greek livestock industry, and it is one of the most traditional breeds. We can find them primarily at the northern and central regions of Greece. These cows can adapt to the Mediterranean climate, and they are characterized by their durability in different environments, while they can use food even from the least fertile soils. We utilize them more in the meat sector for their carcass because their milk production is in a low amount and is only enough for breastfeeding their calf. Genotyping of SNP 11646 of FGF2 gene. We extracted DNA from blood samples from 174 cows from the Agricultural Cooperative of Kastaria. A 207 BP fragment of SNP 11646 of the FGF2 gene was amplified by PCR. These PCR products were digested using CSP6I restriction enzyme and resolved by electrophoresis on 1.5% weight per volume agarose gels. Using this RFLP-PCR method, the two alleles, adenine and guanine, of SNP were indicated by bands of 207 and 171 BP, respectively. In this picture, we have the PCR amplification of the FGF2 gene locus. And here, we have the PCR product first, then the ladder, and the three genotypes. The first genotype is the homozygous wild type, then the heterozygous genotype with a mutation, and the last one is the homozygous genotype with a mutation too. For the SNP of STAT58 gene, 820 BP fragment was amplified by PCR. Then the PCR products were digested using BST-E restriction enzyme. Using this RFLP-PCR method, the ketosine and guanine alleles of SNP 12195 were indicated by bands of 820 and 676 BP, respectively. Here also we have the PCR amplification of the STAT58 gene locus. And the next one is the PCR product of the STAT58 gene, the ladder, the homozygous genotype, the wild type, then the heterozygous genotype with a mutation, and the homozygous genotype with a mutation too. In this slide, we have a table with the genotypic and allelic frequencies in the two studied genes. The allelic frequency for the FGF2, the guanine has a higher frequency from adenine, and for STAT5A gene, the ketosine has a higher allelic frequency than guanine. In the present study, we investigated the genotypes of the FGF2 and STAT5A gene polymorphisms in the Greek red cow breed. Since these two single nucleotide polymorphisms have been reportedly associated with fertility traits, it was considered important to determine whether the desired genotypes were present in this Greek breed. The desired genotypes are present in Greek red breed cows, and it will be very interesting to perform association studies between these SNPs and reproductive parameters. However, further work is needed in order to confirm these associations in this breed. Once confirmed, these SNPs could be incorporated in a larger panel of markers to assist breeders in selecting cows with improved reproductive rates. The project is genetic improvement and promotion of livestock products from Greek farm animal breeds using modern methods of sustainable development and gene technology. This project was funded under the Measure 16 Corporation in the framework of National Rural Development Programme and is co-financed by the European Fund for Rural Development and a national budget. Thank you for your attention. Does anyone have any questions?
You asked on your own, very good. So congratulations for the nice presentation. Any question from the audience? No, just a very, very small question by me. Firstly, it's very important to work on this breed and in general in the so-called Greek breeds, like the red cow, which is I think, the only one, bovine certified, improved Greek breed. I just wanted to ask you, have you compared, are the same genotype frequencies in other meat-type bovines, breeds from the rest, let's say, Europe, or from other regions?
No, just red Greek cow. Yes.
No, I mean in the literature, if you checked, or
Yes, I have checked.
It's more or less the same, or you didn't already compare them?
Can you
did you already compare your results with other breeds? Have these genes been genotyped in other breeds from other parts of Europe?
No.
Okay.
Thank you.
Thank you very much. Okay, and we can proceed to the next presentation, which is entitled Enhancing Precision Livestock Management with IoT, Insights from the Wellness Project, and it's going to be presented by Mrs. Anna Maria Iatrou, and it's going to be by Zoom. So,
good morning, everybody. Glad to be here to introduce you to our project, Wellness Project. The utilization of information and communication technologies in livestock management has revolutionized traditional farming practices, enabled both farmers and veterinarians to operate with precision and efficiency. ICT technologies facilitate real-time monitoring of animal status and in supporting productivity and sustainable farming practices. This integration allows for the systematic monitoring and evaluation of critical parameters that can be used in order to assess animal welfare, leading to a reduction in overall costs and human errors. Thus, an efficient and specialized decision support tool for livestock management and milk production is essential. Wellness Project focuses on the development of a comprehensive system for recording productive parameters and holistic management of sheep and goat farms in milk-producing regions. Wellness provides real-time measurements from livestock environments, enabling a systematic monitoring and evaluation of the most critical parameters in order to assess animal welfare. The wellness system monitors and records data on animals, farming operations, and environmental conditions in the farm using IoT sensors, alerts farmers to potential health issues, provides the ability to read, process, and display detailed information at the individual animal level, recognizes potential problems in real time, and aims to support local cheese dairies by improving the quality characteristics of the milk produced, thereby enhancing the value-added products derived from dairy processing. The pilot case is implemented in 2 cheese dairies and 3 selected dairy farms in Bourinos area, in Bourinos Mountain in the prefecture of Kozani area. This initiative aims to ultimately improve the organization and efficiency of milk production in sheep and goat farms. Regarding the data collection, Wellness to enhance precision livestock management leverages the power of the IoT to gather comprehensive data from 2 semi-intensive dairy goat farms and 1 intensive dairy sheep farm. It employs GPS trackers in order to monitor the movement pattern of sheep and goats. 2 of the farms were equipped also with meteorological stations in order to collect weather-related data. And at the end, this strategy enabled us to integrate environmental and coordinate data in order to determine well-being indices and milk quality specific to the Bourinos Mountain region. Agrometeorological stations measure a variety of parameters, including temperature, humidity, etc. The data collected by this station provide critical insights into the local climate and environmental conditions, which are essential for optimizing livestock management. The comprehensive environmental data provided from the stations assist farmers in making informed decisions, therefore improving animal welfare productivity, and the long-term viability of their livestock. The wellness project uses GPS tracking technology integrated into animal collars in order to monitor their moving and their behavior. I will not delve into many details because I'm not the expert in this part of our job, but the essential elements of the collars are the GPS Neo module, a DHT11 temperature and humidity sensor, an SD shield and a lithium polymer battery, and a LoRaWAN technology. A printed board has been designed for collar, which helps in reducing both the size and the weight of device so as to be easier and more convenient for the animals. Here is the printed collar that our partners designed. Regarding the animal well-being indices, monitoring seems to incorporate indicators that possess validity, reliability, and sensitivity. A series of environmental indices has been selected in order to assess the overall animal well-being. These thresholds include thermal stress and air quality measured by calculating the air quality index. Precise measurements are made regarding the microclimate conditions of the environment in the farm. And these environmental indices, along with data gathered through the GPS trackers, are used in order to develop a complex index pertinent to the sustainability assessment of food and agricultural systems of FAO guidelines. Wellness platform at the end is developed with the purpose of collecting real-time data and providing the capability to read, process, and display details in a user-friendly manner. The application will support 3 roles for farmers, vets, and cheese makers. For farmers, the platform will offer the ability to use the user to monitor the animals, to receive weather data, and view information about their production. The application will also offer the capability to alert the farmer about potential health issues concerning their animal. Regarding the vets, they will have access to monitor the animals, to input key welfare indicators of individual animals, receive weather data from the agrometeorological station, and view information about the production of the animals, such as the number of milking animals and details related to quality and quantity of the produced milk. At the end, these makers will be able to input data regarding the quality and quantity of the milk that they receive from each farm, and thereby enabling the tracking and evaluation of milk production progress. In conclusion, the Wellness Project effectively illustrates the advantages of IoT technologies in livestock management. The use of IoT sensors, smart collars, and a specialized platform can lead to a more precise and efficient operation, improving productivity and sustainability of the farm. By deploying a comprehensive system for real-time data collection, the project significantly enhances the monitoring and management of the farms. The tailored functionalities for farmers, vets, and cheese makers will facilitate informed decision-making in order to ensure high-quality milk production and the economic viability of the farms. The upcoming activities of the project include also the development of the welfare index based on the microclimate conditions of the farm area. And the project was funded under the Measure 16 cooperation, funded by the European Union and national budget. Thank you.
Thank you very much, Mrs. Iatrou. Very interesting, this platform. Let me first give the floor to the audience if there is any question. Yes, please.
Hi. How do you plan to measure the wellness being? How do you plan to implement such a metric?
We will measure some basic welfare indices in the animals, like under asymmetry or any thickness or problems in legs, and we will have the ability in order to our partners of CERF will develop this an algorithm that they will include all this data. I'm not able to answer you now how it will be developed, but because we have not started yet this procedure, we are still in we are still collecting all the data, but we can come up with extra information and maybe report our results later on.
Thank you, Ms. Iatrou. I think we can proceed, since the time is okay, tough. We can proceed to the next presentation, thank you very much, which is entitled A Comparative Analysis of LSSVM and Random Forest Models for Sensor-Based Lameness Detection in Cattle, and it's going to be presented by Mr. Konstantinos Dolapsis.
Hi, I'm Konstantinos Dolapsis. I'm from CERF, and my presentation is about comparative analysis of LSSVM and random forest models for sensor-based lameness detection in cattle. So, firstly, what is lameness? Lameness is a condition that affects the animal ability to walk properly. Lameness causes a major welfare issue, limits mobility, reduces milk production, and harms reproductive health. And finally, leads to increased veterinary costs, economic losses due to decreased productivity, and pain and distress for the animals. Now, how can we detect the lameness? There are several methods in order to detect lameness. Other are more traditional, and other are more innovative. The traditional methods rely on visual assessments, but they are subjective and prone to error, require constant monitoring, and the most times can detect lameness in a later stage. From the other hand, innovative methods include the computer vision methods, where we are using cameras that are watching the movement of the animal and can find some signs that are associated with lameness, such as some head bobbing or back arching. We can also use pressure-sensitive perlays, where we are leaving the animal to walk in a path, and we are using some sensors that can measure the pressure distribution. There are also IR cameras, which are mainly thermal cameras, that measure the temperature of the animal. And in regions that, that there is lameness, the temperature is higher. And finally, we have the IMU sensors that we used in our project. Specifically, we used the Blue Trident by Vicon IMU sensors. We attached these sensors to cattle lips in order to track the movement. These sensors were accelerometer gyroscope for X, Y, and Z axis. We had a sampling rate of 500 hertz, and we finally left the animal to walk freely for about 10 minutes. So now the data that we extracted from the sensors were imported in Python in order to to proceed data pre-processing and training. We created 6 columns as prediction values and 1 as predicted value. The prediction values were the values from the accelerometer and gyroscope from the 3 axes. And the predicted value is the condition of lameness. We had in class 1 the mild lameness, in S class 2 the severe lameness, and S class 3 when the animal is healthy. We also used 10-time domain features extraction using sliding window of 2 seconds with 50% overlap. Then we used the NCA algorithm in order to keep only the features that have high correlation. And so the final selected features were standard deviation and maximum value for the y-axis of the accelerometer, the zero crossing in the x-axis for the gyroscope, and the signal area across the z-axis for the accelerometer. So we have finished with data pre-processing. Now we need to choose the appropriate machine learning models. We use 2 well-known models that have been used many times in similar applications. The first is the least square support vector machine, and the second is the random forest model. In order to choose the right hyperparameters that will train our models, we used, in both cases, the grid search method. And for the first model, the LSSVM, the hyperparameters are say equals to 10 and gamma equals to 0.05. These 2 hyperparameters are related with the penalty that the model gives during training for misclassification. And for random forest, we use the number of trees equals to 100. The Gini criterion function for split quality, the maximum depth equals to 10, and finally the minimum samples to split a node equals to 2. In this slide, we can see the 2 confusion matrices with the results of our models. As we can see, both models have good performance in recall, overall accuracy, and precision. But random forest outperforms for a little in terms of precision, recall, and accuracy. We can also see the recall in both models is very high. And so the recall in severe lameness in both models is high. And so we can conclude that cows with severe lameness showed clear movement patterns detectable by sensors. The recall in mild lameness, as we can see, is lower than the 2 other conditions. And as a result, cows with mild lameness had more subtle movement variations, which were harder to distinguish from healthy cows. So in conclusions, in our project, we made lameness detection using IMU search sensors and machine learning models. We tried the least square support vector machine and random forest. Both models demonstrated high performance. Random forest exhibited slightly superior results. And finally, for a future work, maybe we could use sensors that have enhanced IoT capabilities in order to be able to send the sensor data automatically to cloud in order to perform some CI, continuous integration and continuous deployment proceedings full automatically. Thank you. I don't know. Any questions?
Thank you very much. Very interesting. This platform. It's very, very interesting, and for the nice presentation. Is there firstly any question from the audience? Okay. Very fast question. Can it be applied in both intensive and extensive farming? Because sometimes if there is small space, again, it works properly. Have you tested it? In the intensive farming, so if we are only inside the farm, again, or it has been...
external farming?
Yes. Or it has to be out in the field only to work?
There is not problem.
There is no problem.
It can be used either in internal, external farm. If there are the sensors attached to the animal, then it can send, if there are IoT capabilities in sensors, then they can be resent in cloud.
Okay.
It doesn't need to be
in a space
inside the farm.
Okay. Thank you.
We can use it for sheep
in extensive farming, in a grazing pasture.
Yeah.
Okay. Thank you very much. So if there is no other question, okay, Aphrodite, yes, please.
Data in order to may I ask something, please, about the collection of the data before feeding them in the training models you used in the machine learning? How many sensors did you apply, and in which time zones? Does it play any crucial role if it is early in the morning or late at night? I know you talk about lameness, but are there any other agent-based criterion that changes maybe the data you used?
We used 4 sensors, one sensor for attached each limb.
Yes, but in how many animals?
In 6. We used for 10 minutes for each animal. We had data for 10 minutes from 6 animals, 2 from each condition, in order to train the model.
Okay.
And it was early in the morning.
Thank you very much.
And later we tested in another animal. We didn't make the training and the testing to the same animal.
Thank you.
Thank you very much. So I think we can proceed to the last presentation of the morning session, which is entitled Development and Laboratory Testing of a Bucket Milking Machine with Flow-Controlled Vacuum based on an NI data acquisition system, and is going to be presented by Mr. Radu Rosca from University of Life Sciences in Romania. And it's going to be via Zoom. Thank you.
Good morning, everybody. I'll start by saying how much I regret not being able to be there in person. If I'll tell you that there are 5 degrees here in Iași, so you'll understand why I miss being in Greece, but that's the situation. Okay, I'll try to be short. In fact, this paper was, let's say, a development of an earlier paper which was presented at the HAICTA conference in 2015. A paper which was dealing with using a variable frequency drive in order to regulate the vacuum level in a milking system. Of course, I will skip the introduction. I guess everybody knows how a mechanical milking system works. The idea came to me and my colleagues from a paper You see its first page on the left, from a paper where the idea was to adjust the vacuum level as a function of a flow rate of the milk. And there were some good reasons presented in that paper why we should consider this solution. I will not enter into many details because the paper is available online, everybody can read it. So we decided to, of course, the previous paper was also started from an idea from some other authors, which concluded that using a variable frequency drive to regulate the vacuum could bring some economy in energy consumption of the milking machine. So we took a step forward to the existent bucket milking system, which was completed with some flow transducer, and of course the milking system itself, the bucket milking system itself was connected to a data acquisition system in order to read the vacuum level and the flow rate of water. That I should have mentioned, but in the previous paper the tests were dry tests, no liquid in the system. In these tests, these tests were wet tests. We have used water instead of milk in order to make the experiments. There's a diagram on the left here of the milking system, and even a picture of the system during the tests. Okay. Of course, we have used, as I said, a data acquisition system from National Instruments, and the LabVIEW environment was used in order to process data and to control all the system. As any application in LabVIEW has any virtual instrument, which is the dedicated name, has a control panel like this, and then it has behind the program itself, the block diagram of the virtual instrument. The idea was to, as I said before, to adjust the vacuum level as a function of the flow rate of the water through the system. The variable frequency drive was controlled with a PID controller, also developed using the facilities of the LabVIEW environment. The main problem here was how to establish the threshold reference for the water flow rate, which makes a difference between low vacuum and high vacuum level. Based on some other results presented in other papers, we decided to set the flow rate at 1.94 liters per minute, and also to set the low vacuum to 0.42 bars and the high vacuum level to 0.45 bars. Of course, The first, as I said, it was a PID controller, so the first step was to tune the PID controller. Of course, in the previous tests, the PID controller was tuned, but we had only dry tests at that time. So the situation has changed right now because we were performing wet tests, so we had to tune again the PID controller using the Ziegler-Nichols tuning rules, and we finally calculated these values for the constants which are involved in the PID, in controlling the PID controller. And I have attached here a graph which shows the variation of the vacuum level in time. The theory says that the PID tuner should be tuned in such a way that the oscillations should be of the same level. So this was the final chart which led us to calculate these constants on the left. Okay, in any vacuum mechanical milking system, the most important the most important issue is vacuum stability, and the ISO standards state that a maximum fluctuation of plus minus 2 kilopascals is okay, below or above the set vacuum level. So the first test was to see if changing the vacuum level has allowed us to attain these requirements of the ISO standards. So in this chart we can see that changing the vacuum level from 0.45 to from 45 kilopascals to 42 kilopascals did not led to vacuum fluctuations exceeding the limits of plus minus 2 kilopascals. You see here these lines in let's say green and violet set the limits of plus minus 2 kilopascals. Then, of course, the tests with the wet tests have been performed in the following manner. We have first started the system. We have waited until the system has reached an equilibrium and the vacuum level was constant and 42 kilopascals. The flow rate then was increased over the threshold value in order for the vacuum to reach the higher value, and then the flow rate was again diminished or reduced to 0. And we have here 3 charts that show the results for different situations in which we have tested the system. The different flow rates, yes, and even when the flow rate has been completely shut down. The conclusion of this test was that, as you can see, there are vacuum fluctuations on all the charts, here and here, here and here, here maybe, and even here, but they did not exceed the plus minus 2 kilopascals limit. But we wondered if we can diminish these fluctuations, because as the literature tells us, the existence of liquid water or milk in the milking system results in such fluctuations. These are the results regarding the values of the average vacuum system and standard deviation of the vacuum values. As I told you, there weren't any higher fluctuations than 2 plus minus 2 kilopascals, but I was saying we have tried to diminish these fluctuations, and let's say the first step was to change the original claw of the milking system, which is this one, with a larger one, which is here. And here are two graphs for the same conditions as the previous ones. And the table shows us that the vacuum fluctuations were diminished by increasing the volume of the claw. So, all these tests have shown us that the solution is a feasible one. Of course, in order to use it, let's say, commercially, we should move from national instruments and LabVIEW and things like this, which are very expensive and not very common to the usual user. We should switch to a more cheap solution, let's say maybe using some software and data acquisition based on Arduino. This could be, I guess, this could be a solution to make this system feasible. I should add here that such a milking system, a bucket milking system in Romania, its cost is, let's say, 300, 400 euros. So maybe if we can switch to another solution in terms of hardware and software, maybe we could not increase its price too much. Well, I have no idea right now how much would be this increase, but it remains to be seen how we can switch from this LabVIEW environment, which is very easy to use, to a more difficult task like programming the Arduino microchip and things like this. Okay, I guess this was everything I had to tell to you. I hope I haven't made you asleep like here. Thank you very much for listening, and I wish you a pleasant pleasant days in Samos. Thank you so much for listening.
Thank you very much. An interesting machine. Firstly, is there any question that I can give the floor? No? So if there's no questions, this is the end of the session number 3, entitled Livestock and Aquatic Production Systems. Now there is a break up to 12:15, coffee break, and then at 12:15 up to 2 o'clock almost is the 4th session. So let's have a little break and be back here at about 20 minutes, let's say.
Hello. Let's start our new session. This is session 4, Training and Advisory for Efficient Management. I will be the chair of this session. There has been a slight change of the program. Let's start. We have also orals and telepresentations. Let's begin with the first presentation presented by Mr. Levente Peter Balint, University of Debrecen in Hungary. Hello. It is about towards Agriculture 5.0 in the European Union. Okay, you may start. I remind all the presenters that it will be strict 10 minutes presentation because we have many of them. Okay? You may begin. Thank you.
Now, it is fine. Okay. Good afternoon, everyone. I hope you had time to refresh yourself in the break. My name is Levente Peter Balint, and I'm a PhD student at the University of Debrecen. And today I'm going to talk to you a little bit about digital skills in the agriculture sector. So, as the concept of agriculture 4.0 is a very important thing, it also brought forward the importance of digital transformation in companies, as well as the utilization of digital technologies in order to achieve not just resilience in the agricultural sector, but also make the processes more efficient. While sustainability principles are coming towards each big European policy, and they are getting implemented in, it is also parallel that a demand is rising for individuals and workers who just do not possess the modern technological agricultural skills, the hard skills and also the soft skills, but also digital skills in order to implement or use a digital technology or to reform certain agricultural processes. It is usually happening in urban areas where universities we teach agricultural engineering students how to use digital technologies. It is important to give them digital competencies that they can leverage these changes. We performed a keyword analysis using the digital skills and agricultural combinations. And from the papers, we concluded that digital skills are getting more and more emphasis in the agricultural sector. And it will drive the what's the word? Sorry, just can't remember. The competitiveness of the agricultural sector itself. In our introduction, we can say that digital transformation usually have barriers in every sector. Agriculture is not an exception as well. I can highlight now the lack of digital skills and the tech competencies of individuals, and also the lack of skilled labor, which is always a huge problem in the sector. With agriculture 4.0, which also moving the innovation in the agricultural sector, it is said that we need to not just train individuals who can basically carry on implementations of digital technologies and transformations, but also they can optimize processes using sustainable principles. And as I mentioned that, this will also transform in a way that conception, or it will resolve that misconception that the agricultural jobs are usually considered as low-skill occupations, but we will see. In our methodology, we basically performed a trend analysis using Eurostat datasets, and our Hungarian higher education graduate tracking database. We collected data about agricultural engineering students and how they got into the work market in a whole, and what occupation they filled in. So we can see that we have a small decrease due to the pandemic, but the numbers are getting back to the normal trend. We will see. This is an interesting research because in the literatures, we haven't found any previous papers that would use a representative database, a market database, for concluding similar results. For the Eurostat data sets, we used digital skill indicators from the Eurostat, one for the online information and communication skills and one for the basic information and data literacy skills. And for the results, after we analyzed our trends regarding the occupations, we concluded that most of the agriculture engineering students did not really got a job connected to their close academic degree because of several reasons, but one of the most important was that they found that other industries or supporting industries to the agricultural economy itself was more appealing for them, but we need to move them or retain them from getting jobs or filling occupations elsewhere because we already have an issue with skilled labor, so this needs to be maintained. For our data literacy skills, for the normal eye, we can say that we are doing well, but that is not really true. Usually, northern and western countries are performing well regarding digital skills, but if we look deeper into the more advanced skills, we can see that most of the countries basically report 0 for agricultural workers, but for those who are performing well regarding like Germany or Romania or Belgium, they are doing well and they recognize that there's a need for online information and communication skills, which would be a real tool for the concept of agriculture 5.0, sorry. For the conclusions, we concluded that, okay, we are getting back to normal regarding graduate numbers in the agricultural field, but the challenge still stands because we need an idea how to retain these graduates moving to other industries, and also it would be a really good solution to ease the lack of skilled labor shortage. And that would be all, I think. Thank you so much.
Thank you very much for your presentation. Any questions? I have a small question about you. You said about digital skills. What are these digital skills you say here in our presentation?
There are many digital skills regarding how to handle data, how to maintain data, how to basically recognize that, how we can basically recognize the data sources within a company. Usually that's the most problematic thing, and there's a specific the problem-solving skill, digital problem-solving skill, how they can manage to get that data basically available to the management, for example, and it is sometimes hard because there's no one who could basically collect and analyze data.
Thank you very much, and keeping also the time.
Okay, thank you so much.
Now we're moving for the second. Yes. Yes. We'll continue with the presentation presented by Mrs. Silvia Botos.
That's me.
Okay. Hello. Enhancing data accuracy in agri-food forecasting, methods and implications for informed decision making. Okay, the floor is yours.
Thank you very much. Yes, thank you, dear organizers, dear participants. My name is Silvia Botos, and I'm from the University of Debrecen. And in my presentation, I would like to present one of our current research that based on not only the forecasting methods and hard skill methodology analysis, but also some soft skills, which are required to do these things, these methodologies, these forecasting. So, as an introduction, I would like to introduce some of the main problems that would be needed to resolve, and these are the valuable insights in the sectors. Agriculture is one of the sectors that not really competitive regarding the data analysis and data management. However, agricultural sector has many resources that are available for not only research but to use as financial analysis and both for sectoral analysis and make a competitive advantage. The new policy, the European Union's food policy by 2030, innovation and sustainability with competitiveness and resilience will be a focus. And also, for us, data analysis is a really good point that we can connect to this area. The Digital Decade and the Digital Europe program are two very good program that contain the operational performance of the enterprises, how to enhance them, and what are the objectives. So from our side, we tried to use open source software to analyze data, and we selected market prices as the basis of the analysis, and I will show you the result, how to use this type of open source system. And I would like to present also some technologies based on digital technology implementation. What are those technology elements that can help us and help also the young farmers to make these analyses? First of all, we created a literature review, and the focus of the literature review was the open source. As you can see, this is the center of our research, and as you can see, in different research works with agriculture, with Python, other open systems, and we can identify also the clusters on this picture. You can see that data visualization and also the different very direct lines are very close to the agriculture and data analysis. So this is the integration of the digital solutions and the different strategies also in agriculture. The literature review said that the knowledge transfer is one of the most important things. However, it's very hard to reach the objectives, and this will be the agriculture 5.0. Besides industry 5.0, this is a very important focus of the different strategies. We selected the missing data for our analysis and missing data in time series. We worked together with some of the agricultural experts, and one of the most important problem for them, for example, using a sensor technology, are the missing data. So we wanted to analyze how to create different data management for them. For the methodology, we used the seasonal autoregressive integrated moving average method, and that's the SARIMA method. And we used, as an open source system, the Python-based algorithm for data pre-processing. But we also merged this type of information, this type of data processing with another data set with the skill analysis, and this is the individual's level of digital skills, and I will show you what is the difference between the analysis and also the skills. Our result shows that SARIMA is a very good option when we would like to analyze time series, because it also takes attention to the seasonal variability, which is a very important thing in agricultural analysis. We used the Hungarian agricultural product information system, and we used the market, one of the market prices, and we also used Python to make the transformations of the data and also for the analysis. on this data, on this figure, you can see the adjustment of our analysis. The quantitative values of the actual data showed on the blue line, and the predicted data also you can see on the orange one. This is the adjustment when we have all of the data what we needed. But you can imagine if we have, for example, missing data from the time series, this adjustment will be moving. And this is the quantity values by Holt-Finter's forecasting, and you can see this is the orange. The orange line shows the test quantity data, and the green one will be the predicted quantity data by this model. So it's we can say that it is precise by a way, but what if we have missing data, for example, from our time series or from a sensor technology or anything like this? The model assessment table shows that our R value is 0.66, so the model performance is generally acceptable with a room for improvement, of course. You can see the other statistical values for our calculation. But I have to say that from data to the analysis, we have many steps that we had to do, and our research also contains some summary for those researchers or research activities that we have to do if we want to go from the data collection until the data processing and visualization. And we can characterize this as an ETL process, and that's why I think it's a really important part also of these analyses, not just the hard results for analysis like this, but also the soft skills that we have to use to make these things. As you can see, the readiness for data analysis is not so high based on the Eurostat data set, because basically it contains a lot of readiness components that we can analyze. But this is the time series of the individuals who used, for example, spreadsheets, advanced functions to organize data, analyze data, and these are the advanced functions. As you can see, all of the European countries are on this figure, and you can see that, for example, the maximum values are around 40 and 50 percentages, but there are a lot of countries that are below of the average. So we have to make a development also in this. And what about the readiness for writing programming codes? As I mentioned, we also created our analysis in Python. And Python is about analyzing with programming codes. These codes are not so difficult, but it needs soft skills, soft IT skills at least. And you can see that regarding this type of readiness, you can see that the maximum values are around 10%, and all of the EU countries, most of the EU countries are below of 10%. This is the individual readiness for writing programming codes. This is not a high number, so this is also a missing value, if I can say that. My conclusions, or our conclusions with my co-authors, that making well-informed and data-driven decisions is essential for the modern businesses, including agriculture as well, and the food industry, if we think about the whole agri-food supply chain. Enterprises can leverage secondary economic data as well. FADM, for example, the farm accountancy system, is a really good option with a very good time series and also breakdown of the data to use and to analyze with these things, and also the national databases. Data analytics can be used in agriculture for many areas, and we can create accurate market analysis as well using using the prices, using the quantities, and also other direct information. And this approach fosters more informed decision-making and contributes to greater efficiency and profitability. However, we have to improve also those workers that can use these skills during their work. So thank you very much, and thank you for your kind attention.
Thank you very much. Does anyone has any questions? Yes.
Yeah.
Can you go back in the one slide before the conclusions when we see those data distribution?
Yeah, of course.
Right, one more, right there. From what I see here, the data distribution, the range, is very, very high. So that probably is what makes the models less optimum. What do you think about that?
This is about the readiness for writing programming codes and excuse me, I didn't catch.
For example, if you look on the vertical in the data, the range of the data is very high. Yeah. So that probably makes the analysis a little bit more unstable, statistically unstable. Do you think if the distribution of the data would be closer, it could have helped to make a better model, let's put it like that?
This is not about the model. This is this comes from the Eurostat, and all of these things are the European, all of the European countries. But of course, yes,
it shows large distribution.
Yes.
I should rephrase my question. It's not your data, of course.
Yeah.
But this large deviation shows that we cannot make a very good decision based on this.
Yes.
And you mentioned that anyway.
Yes, of course, yes. Based on the European Union membership countries, if we can, for example, yes, lower this range, this distribution, yes, this would be very great, yeah.
Thanks a lot.
Yeah. From the lowest one to the highest one, yeah.
Thank you very much.
Thank you so much.
Yes.
Thank you.
Yes, the next presentation is a telepresentation. It is from, it will be presented by Mr. Mokhtar Baraket from Inagref, Tunisia. It's about, it's a comparative analysis of agroecology and agroecological transition curricula in Mediterranean countries. So, Mr. Baraket. Hello.
Good morning.
Yes.
Good morning, everybody. So, can you hear me, please?
Yes, yes, yes. You can. You may continue.
Agreed. So, first of all, I'm Mokhtar Baraket from Tunisia. I'm an assistant researcher. I want to give you today a comparative analysis of agroecology and agroecological transition-related curricula in Mediterranean country. So the focus of this presentation is to make the agroecology and the role of education in advancing sustainable agriculture. So it doesn't move. It's okay. So, as you know, agroecology, it is an integrated approach to farming that considers the ecological, social, and economic dimension of agriculture. It promotes biodiversity, reduces reliance on chemical inputs, and enhance the resilience of agriculture system, making it essential in the face of climate change challenge. So in this case, the university can play and the higher education can play a crucial role in advancing agroecology by integrating into their curricula and their syllabus agroecological model to equip future farmer, agronomists, and the police markers with the knowledge and the skills to promote sustainable agriculture practice. So this educational shift foster innovation and empower the next generation to implement eco-friendly farming method, contributing to global food security and climate change preservation or environmental preservation, let's say preservation. So in this way, the NATAE project, which is dedicated to fostering the agroecological transition in North Africa through a multi-actor approach involving design, evaluation, living labs, replication lab, and networking. It aims to integrate sustainable farming practice and agroforestry system to enhance both ecological resilience and agricultural productivity. So the project is composed, is structured around the 7 work package, and each focusing on different aspects of agroecological transition. And in HAICTA 2024, we have a special session of NATAE, and you can have more idea about this project. So among the 7 work package of our project, the work package 7 is dedicated to education and extension. It is focused in establishing a database and offering insight into agroecology courses and syllabi in the North Mediterranean region. So the work package the work package 7, there is 4 tasks as education, student field schools, professional training, young researchers school, and the tasks 7.1, it's focused on reviewing and analyzing existing education program in the partner country. The aim is of this task is to evaluate the current state of agroecology related course and curricula, to identify the gaps and to provide a recommendation for improving education and training in agroecology among North Africa and the European country and others, as if Algeria, Libya, Tunisia, France, Netherlands, Greece, and South Africa, and around the many institutions, INAT, IAV, USC, Van Gangen University, and others. So the data analysis or the methodology of the work for this task, it started by collecting course and syllabi from various countries. These courses were gathered following an Excel sheet, as you see it, an Excel sheet template, which include different information, such as the country, the university, the faculty school, public or private, the course unity, the lecture, and the semester, many information about the course and about the syllabus. Afterward, and after collecting this information, we are starting to analyze the data. We began collecting the data for each country. It's based on the number of the course. The next step was to categorize the courses, determining whether or not they were related to concept of agroecology. So to do it, we classify our course and module and syllabus, determining whether they are related to agroecology. It was carried based on the key of the principle of agroecology, and especially the following the FAO 10 criteria for sustainable agriculture, as if diversity, co-creation and sharing of knowledge, the synergy, efficiency, recycling, the responsible governance, the circular and the solidarity economy, and then so on. So the data analysis here, we want to give you basically some example of our work. So here you will present the data analysis of North Mediterranean country. So France, Netherlands, Italy, and Greece. The course collected was about 75 courses, and as you see, Netherlands and France are the higher number of courses reported. Italy and Greece have the low number of course reported. The Netherlands, it's quite balanced with an emphasis on diversity and efficiency, but socioeconomic are fairly studied. But for Italy, you see that it's quite balanced, and the clear focus on both agronomic practice and the socio-economic human value and the circular economy. For the Greece, it's mainly related to the agronomic aspect and agroecological practice. As an example, the diversity and efficiency and recycling. For France, the balanced approach with an emphasis in diversity, synergy, efficiency, and recycling too. So to compare the North Mediterranean country to the South Mediterranean country and North Africa, especially Tunisia, Libya, Algeria, and Morocco, which we are collected 32 courses. It's subdivided the 12 in Tunisia, 3 in Libya, 11 in Morocco, and 6 in Algeria. So you can see that Tunisia do impart the important number of introductory courses on agroecology, and it is represented by the 10 criteria of AFO. But it needs some for advanced courses with case study. Morocco, it is focused in human social pillar, as well as culture and food in agriculture ecology transition. But we need some curricula with more courses in various universities to be implemented, as in recycling, in efficiency, or maybe in synergy. So for Algeria, diversity and the resilience are the major focus of the courses, but we need some advanced scores talking not only about agroecology practice, but also about socio-economy and milestone for transition. For example, in synergy, for example, in recycling, in efficiency, it is not really represented in Algeria. And the same for Libya, we reported a low number of courses, and there is a need for courses dedicated to agroecology and agroecological transition, both at let's say introductory level and advanced, potentially with focus on arid environment and arid environment. Yes. So some perspective about this study. So you can propose a new curricula and content introductory to advance to fully cover all agroecological principles. You can always include the NATAE Living Lab and the Replication Lab cases study in course related to agroecology and agroecological transition. And you can make this as a success story. You can design international master program of agroecology for the Mediterranean region. So potentially with the CIAM institution and the Erasmus project. So this is thank you very much for your attention, and this is all.
Thank you. You kept the time, 10 minutes. Any questions about this? Yes? You have one also?
Anybody else except me? I don't want to have all the questions.
No problem. You may ask.
Mr. Baraket, thank you very much. Your data are nice, but let me ask you something. In Greece, if I'm not mistaken, in your graph, you showed only 3 curricula in agroecology based in Greece. If you go back to your slide, that kind of surprised me. And my question is, how many, can you hear me, by the way?
Yeah.
How many universities, Greek agricultural universities, have you included in your survey? To your knowledge, probably you don't know it, it's something, there are 32 agricultural currently universities in Greece. And to my knowledge, all of them, and state universities, and 1 private agricultural university. This is where I'm coming from. And to my knowledge, there are more than that, many more than 3 curricula related. So, could you please elaborate a little bit on that?
Yes. So the collect of information, it was done by the member involved in the project, and they provide us for Greece, for example. So I'm opening now my recap. So for Greece, for example, we have almost more than we have almost more than 30 and 35 than 35 data from University of Thessaly, Hellenic University, University of Thessaly, Union University, University of Greece, from many institutions. But here the analysis of the data, it was done regarding the 10 criteria of FAO. So, for example, you can show or you can find some courses or some syllabi which are mentioned agroecology. But when you analyze the syllabus, you don't find the 10 criteria represented. And this is the problem. It's not. The question is not the name of the course. I can make the name of the course agroecology and for anyway. But the detail of the course, we don't find the 10 criteria or 1 criteria which is represented or which is mentioned by the FAO. And this is the problem of the courses. So in some cases in Tunisia, we have more than 100 courses or syllabi that it was collected. But when you analyze, we don't find the 10 criteria. If we don't find 1 criteria, I don't know, for example, the diversity, the efficiency, or another. So this course for us, it's not a course that integrates agroecological course.
Thank you very much for the clarification. We will appreciate very much if you can send to the organizing committee those 10 criteria. We will appreciate if you can send us to the organizing committee which are those 10 criteria. Thank you very much for your clarification. Appreciate it.
Thank you. Thank you.
Thank you very much, Mr. Baraket. There is no other questions. We may continue. The other presentation will be a telepresentation from Mrs. Mariana Ferrigno, Counselor for Agricultural Research and Economics, Research Center for Agricultural Policy and Bioeconomy from Italy. This presentation, the title is Dania Database for Selecting Irrigation Investments in Coherence with WFD and DNSY Principle, H Principle, a case study within the Next Generation EU funds. Mrs. Ferrigno?
Yeah, good morning to
Good morning.
everybody. I share with you my presentation.
Yes.
I hope you can see it very well. And first of all, I'm pleased to participate to this conference on behalf of a great working group that is engaged in research in water use efficiency policy, sustainable water use policy, in support of Italian Ministry of Agriculture. My presentation will talk about the use of Dania database to implement a measure within a national recovery and resilience plan for the investment in improving of efficiency of irrigation network. Let me do a little premise. Over the last 8 years, Italian Minister of Agriculture has implemented a long strategies to invest on irrigation network for reducing the risk related to drought and floods, and so to defend the agricultural production. And these strategies was applied by programming different investment program with the national and European funds. More recently, a dedicated measure was programmed within the National Recovery and Resilience Plan to increase the efficiency of irrigation system through the development of innovative and digitalized infrastructure and for sustainable agricultural sector, as well as a better adaptation to climate change. The coordinated implementation of all this program was supported by 2 different information systems, SIGRAN and DANIA, developed by my research center on behalf of the Ministry of Agriculture, and that are different applications, but jointly used, they improve the quality of policy programming and monitoring in the pursuit of sustainable development. In particular, SIGRAN is the National Information System for the Management of Water Resources in Agriculture and is the reference national database for the collecting of information on measured or estimated amount of water used in agriculture. Dania is an online database that collects projects on irrigation network, both planned and funded, and both for irrigation improvement or for the protection of agricultural production by natural hazards like floods and slope. For each project is contained in Dania, financial, technical, and environmental information are collected in 4 homogeneous sections of data. This information helps to catalog each project and then select them according to objective criteria and parameters that can be useful also in the monitoring of funded projects through the quantification of appropriate indicators. The database model and the data stored in Dania were outlined in the 2020 edition of HAICTA of this conference and then deepened in a published paper. Over time, Dania has been used in all steps of an investment programs, including project application. Together with SIGRAN, it was used in programming, implementing, and monitoring of the investment measure in national recovery and resilience plans. In particular, today I would like to focus on how Dania was used to apply projects and for their selection to be funded within the measure and with what result. Dania was the instrument, as I said, through which the projects were submitted by irrigation board to be funded on the measure and selected according by eligibility criteria and selection criteria settled down by Ministry of Agriculture and automatically applied based on information collected in Dania. These eligibility and selecting criteria were settled down in order to fund intervention able to guarantee water saving and water use efficiency in line with the objective of Water Framework Directive and with the do not significant harm principle. Here we can see the eligibility criteria And some of these 23 eligibility criteria were linked to the type of intervention consistent with the measure objective and with the timing of realization, with the measure deadline, the presence or installation of a matter as supply source to measure the amount of water abstracted, the no net increase in irrigated area, and the compliance with the volume monitoring requirements and their communication in CBM. About the NSHA principle, the fulfillment of the 6 environmental objectives specified in the European regulation was translated into the compliance with the 7 specific eligibility criteria and corresponding value inserted in DANIA. So the fulfillment of all eligibility criteria was automatically a guarantee of the fulfillment of the NSHA principle. For the ranking on the eligible project, 11 selection criteria has been settled down related to the project effectiveness in achieving target, on the impact on their impact on the environmental objective of efficient use of water, and in supporting the typical geographical product. Let's focus on the selection procedure. From June to September 2021, Irrigation Board submitted their project in DANIA, declaring their willingness to apply for funding within the measure. And for a successful application, they had to insert all the information necessary to evaluate, to check the eligibility and selection criteria. This check was carried out outside DANIA by implementing an Excel spreadsheet to process the data declared in DANIA, because currently DANIA doesn't provide any data processing functionality. And the effectiveness of this procedure has been analyzed, first of all, in terms of the reduction of the evaluation time, and comparing with the same occurred in the previous program of investment. And in particular, both in terms of days occurred per number of eligible projects, and referring the whole phase of project selection from the end of the call for funding to the publication of the list of the funded project. So we have found that a strong reduction of the number of days occurred per each eligible project compared to the previous program. And then, considering the wool selection project, we found a reduction of days occurred per funded project, and about 70% less than the previous procedure, and a great increase of funded amount per day of evaluation, up to 7 times the previous one. So this result shows that the use of DANIA for the selection process markedly reduced the time required for identifying the funded projects. Another analysis was about the reliability of the information inserted in DANIA. We found that for the 69% of projects, no data was corrected by the expert group appointed by MASAF to carry out the project appraisal, the eligibility project appraisal. For the remaining 13 projects, only 14 incorrect data were found, and regarding 3 selection criteria, whose evaluation by the irrigation boards was susceptible to a certain degree of subjectivity and or error. But if we consider this number of data in respect to the whole number of insert data, such as 11 selection criteria for 42 projects, we found that the percentages of error is very lower, about 3%. And this allows us to argue that the applied procedure selection is reliable and that in general the irrigation boards enter accurate information. Here you can see a deepening about the causes of error for incorrect data, but let me quickly go to the conclusion. At the end of the analysis, some critical issues and the possibility of improvement can be highlighted. First of all, this multi-criteria procedure proves suitable for the evaluation of projects that whose technically validity and coherence with the territorial need have been previously assessed. And that's why projects in Dania must be previously accepted by the reference regions, which characterize them with an intervention priority level. Furthermore, although some verification mechanisms and procedures are in place to ensure the completeness, the accuracy and consistency of inserted information, a formal verification of the project by the funding body is already needed. But a procedure for verifying and formalize the data, for automatically verifying and formalize the data, is currently under consideration. And finally, there is a potential for duplication of projects in Dania because individual projects may be grouped or split to fulfill the specific funding goals. So a solution for the future could be to develop an application mask that is linked to but independent of project data. Thank you for your attention.
Mrs. Ferrigno, thank you very much for your presentation. It was very quick and it has everything we wanted to see. Anyone has any questions? A small question, maybe I didn't understand something. We are talking about open sources databases, eh?
Yeah.
Yes. Okay. Also, the Sigrian is open source. It is throughout Italy.
Yes, there are open source databases, but they are accessible or on to authorized subject, and that is regions, irrigation boards, ministries, and river basin district authorities. All the subjects that are responsible for planning and realization of these projects and for the programming of policies for water use. So they are not accessible to all users. Even a part of this information for the future will be disposable on the website of the two databases, but in an elaborated manner.
Okay. Thank you very much. Thank you.
Thank you.
Congratulations. Yes, we may continue. The next presentation is from Mr. Anastasios Michailidis from Aristotle University of Thessaloniki. He will talk about, he will present the publication Greek Farmers' Perceptions of Precision Agricultural Technologies.
Thank you, Professor Koundios. Okay, hello. My name is Anastasios Michailidis. I represent the Aristotle University of Thessaloniki, and as you can see, I also represent my colleagues for 4 universities, from the Agricultural University of Athens, from the International Hellenic University and from the University of Western Macedonia. The title of my presentation is Greek Farmer Perceptions of Precision Agriculture Technology. This work is part of an Erasmus Alliance for Innovation EU-funded project, the Boost project. Okay. HAICTA 24 is a very good opportunity for us to disseminate our project and to present some results for the Greek case study. The main objective of the Boost project is to boost agribusiness acceleration and digital networking by providing a sophisticated business training program in the field of precision agriculture by linking higher education, vocational education, training, and farmers. As a secondary objective is to offer farmers and students the required technological, digital, managerial, and environmental skills to effectively deal with precision agriculture. The duration of the project is 3 years, from October 22 to September 25. Now we are at the last years of the project. Okay, you can see the partners of the partnership. There are 4 universities from Europe. There's the University of Thessaloniki as an umbrella of the rest of the Greek universities, the Polytechnic University of Marche in Italy, the University of Ljubljana, and the Agrarian University of Slovenia in Ljubljana. There are also 5 private companies from Spain, Bulgaria, Italy, Germany, and Greece. There are 3 farming associations from Italy, Greece, and Spain, and 1 vocational training company from Cyprus. You can also see the web page, the working package interactions, the PERT diagram. As you can see, there are 4 developmental work packages. The first one is the training needs assessment. This work is part of this work package. In this work package, a huge work has been made. Several research activities and surveys have been implemented, both quantitative and qualitative, in all the countries, all the case studies of the project in 6 countries. Now I'm going to present you only a small part of the Greek case study, the qualitative part regarding interviews to farmers. The second work package is about setup of the education modules. The first one is the theoretical training implementation, and the 4th developmental work package is the practical training and mentorship program. There are also some supporting work packages, the project management, the quality assurance, and of course the dissemination and the exploitation. Recent agriculture faces several challenges, especially in the Euromed countries. New roles, new tasks, new duties for farmers and researchers, new ways of working on farms, and new ways of approaching research. New skills are needed, and there is more than ever a need for efficient upscaling programs targeted at farmers towards digital agriculture, mainly to identify the knowledge deficits and design in order to appropriate competence development plans. The main aim of this study, of this paper, is to understand how Greek farmers view precision agriculture technology and its impacts they have on farming and agri-food systems. As I said before, this work is a qualitative research using open type questions based on in-depth interviews to 8 farmers from Central Macedonia in Greece. You know that the success of this methodology based on the selection of the farmers, of the, let's say, the experts. These farmers are not typical farmers. Has been very carefully selected using a specific selection procedure. We're trying to find farmers which are opinion leaders, which are successful, recognized by the others, with great economic results, with at least secondary education, some of them 1/3 of them have a tertiary education. And of course, farms that has been involved in precision agriculture projects. So they are acting as experts in our work. The same and the other case studies in the rest European countries. Although all the farmers understand that the technological achievements are going together with precision agriculture, it was very interesting that that they do not have clear picture of what precision agriculture is. Each of them offered different definition. Two of them emphasized the information and data. 5 farmers focused on the technologies used in the farms, and none of them referred to the other aspects of precision farming, for example, to the socioeconomic dimensions, to the adoption to fusion dimensions. From a practical point of view, farmers recognize the benefit of precision agriculture to the agri-food system, to their farms, and to the society. Most of them underline the contribution of precision agriculture to the reduction of production cost and the improvement of production quality. Farmers have great expectation from precision agriculture. For example, one of them mentioned that precision agriculture can offer useful data to organize your next steps, while it is a kind of a tool that facilitates the entrance of changes in the enterprise. One participant stressed the importance of precision agriculture for society, since he believes it can offer new job positions. Besides, precision agriculture technologies can positively or negatively impact farms and agri-food systems. For example, some of them recognize those technologies lead to the limited use of pesticides, agrochemicals, and fertilizers. One farmer expressed his concerns about precision agriculture technologies, and two of them seem biased toward precision agriculture since they mention only positive impacts. Farmers believe that in the future they can rely on technology since it can lead to increased incomes, reduced production cost, and improved farm performance. For example, one farmer mentioned that digitalization of agriculture is the next step. Big data would facilitate farmers' work and their everyday life. Some farmers stressed their fear of technology. For example, one farmer mentioned that in the future farmers will be fewer and that the prices will be bigger. Concluding, precision agriculture is viewed as a positive development with a highly transformative potential for farming and the agri-food sector. But farmers are not able to define precision agriculture, mainly due to the nature of techniques used to promote digital technologies and due to the overemphasis of the promises of digitalization. However, farmers' general attitude towards these technologies continues to be positive, despite their concerns about negative social impacts on precision technologies, their misfit with the Greek cultural sector, and high cost of technology purchase. And of course, about cultural and structural discussions they can cause. One very interesting issue is that when comparing the results with other countries, we saw some differences and some common results. For example, we found that Greek farmers and Italian farmers have a common understanding of precision agriculture. On the other hand, the countries of the Eastern Europe, for example, Bulgaria and farmers from Bulgaria and Slovenia, have a more negative view regarding precision agriculture. And on the other hand, farmers from Spain was the most positive one. Thank you very much.
Thank you very much, Professor Michailidis. Any questions? I believe that the presentation was very comprehensive. A quick question, if you may. Yes. There is also a web platform called Boost.
Yes, there is a web platform. All this work leads to the organization of a training material in a Moodle platform, the Boost training e-learning platform, which is ready. And now we are in the stage that we start collecting, start training the farmers and the university students. We have a vision to train more than 300 university students from all over Europe and more than 100 farmers from all over Europe.
In the future, will be accessible to anyone?
It's still accessible to anyone.
Thank you very much. Great work.
And for you, it's also accessible.
Yes, I've seen it.
Before
Okay.
closing my presentation, it's very important to mention that all the farmers would like to be part of the precision agriculture. They want to work with precision agriculture, but they have a fear. They don't want to take any risk. That's why they ask us to work with the university and to share the risk with the university. And this is very interesting results because precision agriculture is an expensive technology, still expensive technology, and needs some support to the farmers. Okay, thank you very much.
Thank you very much. Let's continue with the next telepresentation. This will be presented by Mr. Lukas Polacek from Czech University of Life Science, Prague. The title will be The Impact of Data, Information and Knowledge from Precision Agriculture on the Economy and Business Management. Mr. Polacek?
Yes, can you hear me, please?
Yes, yes, loud and clear.
Can you see me?
Yes, we see you.
Perfect. And now I will share the presentation. Can you see my presentation?
Yes.
Perfect. So I can start. So good afternoon, everyone. Today I'll be presenting to you our contribution on theme, the impact of data, information and knowledge from precision agriculture on the economy and business management. But first of all, let me quickly introduce myself and the rest of the authors. My name is Lukas Polacek. I'm a PhD student operating at Faculty of Economics and Management at Czech University of Life Science based in Prague. The main author is actually my supervisor, Associate Professor Edita Schillerová, and the last one is Head of Department of Information Technologies, Associate Professor Jiří Vaněk. So the structure of my presentation is following. First of all, I will tell you some short introduction to this problematic. Then I will talk about use materials and methods, objective of this research, and finally about results and then some brief conclusion. So precision agriculture has emerged as a key trend in modern agriculture, and it has become a trend of the 21st century. It utilizes advanced technologies and data to drive efficiency and sustainability across rural agriculture operations. Precision agriculture replaces traditional farming methods with automation and robotization, optimizing resource usage and enhancing sustainability. Important to mention that adoption rates vary. For example, in America, it's approximately 20% higher than in Europe in precision agriculture technology implementation. Most enterprises lack integrated data systems, still relying only on manual processing via spreadsheets, for example, very well known tool like Microsoft Excel, which limits data usability, of course. The goal of this presentation is to explore how precision agriculture is shaping the agriculture sector, its economic impact, and mainly how data management plays a crucial role in this transformation. Data from precision agriculture can transform agriculture industry. Yes. Now let's discuss the materials and methods used in this study. The main objective of this research is to propose a data model that can be applied to precision agriculture for improving economic and business management within, of course, agriculture enterprises. The main goal is to propose the integration of the obtained data from all parts of agriculture enterprises and the possibility of using them for the assessment of reality and, for example, other stuff like predictions, modeling, etc. The methodology employed includes a combination of scientific methods such as analysis, synthesis, and investigations conducted in various agriculture enterprises used by direct questioning. We aim to integrate data from multiple aspects of agriculture production, management, and economics to enhance data-driven decision-making and predictive planning. We also use, of course, our long-term knowledge and experience and cooperation with practice to process this contribution. On the basis of investigations carried out in 76 selected Czech agriculture enterprises, a methodology for the usability of data warehouses for use in business management was proposed. The purpose model will allow farmers to use data for simulations, etc., as I mentioned already. Integration of data will help in making informed decisions and future agriculture practices and their strategies. So let's move on the first part of results and discussion. Figure number 1 shows that precision agriculture requires mainly accurate data and information, then highly skilled human capital, and software applications or tools. These are main factors that will create ideal resources for further processing and evaluation of economic efficiency. Results and discussion part number 2. The economic benefits of precision agriculture are becoming more evident, but it's still not fully explored. Therefore, we focused mainly on this area. Research demonstrates that precision agriculture can significantly reduce costs, especially in mechanized harvesting. The results in this table show that only 12% of companies use data for economic purposes, or even less for management purposes, while, for example, 48% use it for plant production. This reveals a significant gap in data utilization for business management. Another challenge which we identified is the lack of integrated data systems in these enterprises, with most companies still relying, as I already mentioned, manual processing using spreadsheets like Excel. We also found out that in Czech Republic, it's mainly question, or let's say more precisely, problem of extra expenses which must be invested. Another part of result and discussion, this figure shows a proposal for an integrated database that would make it possible to use all the data generated in the company. To address these challenges, we proposed a data integration system that would consolidate data from various parts of agriculture activities, such as planting, HR, machinery use, labor, finances, SPD, which means sales and purchase department, into a unified database. Of course, the integrated database should improve decision-making, decrease costs, and again, increase competitiveness. Yes, this is last part of results and discussion. Figure number 4 demonstrates how companies can use internal, but at the same time, external data together in order to predict, for example, crop yields and optimize production. In general, this system can utilize internal data in combination of external data for modeling, simulations, planning, and predictions, leading to informed business decisions and to do best efficiency models. Under external data, you can imagine, for example, expected market prices, sales volumes, etc. And here in conclusion, I just summarize that data and information have become essential resources in modern agriculture. The ability of managers to use this data effectively will define the future success of their enterprises. We are seeking a shift where agriculture is becoming a knowledge industry, where leveraging data will drive profitability and sustainability. By integrating precision agriculture tools into every aspect of this business, whether it's production, sales, or management, we can unlock new levels of efficiency and competitiveness and for example, also improve quality of environment. Sorry. And this is basically all from my side. So thank you very much for your attention.
Thank you very much, Mr. Polacek. Questions, please. Yes. Yes. Mr. Gertis, you may have the microphone.
I have a feeling that I monopolized the questions. I apologize to the rest
Just
of
you
them.
and me.
Can you hear me, Mr. Dr. Polacek?
I'm not a doctor, but yes, I can hear you.
Okay, thanks for your presentation. It's not a question, it's rather a little comment I would like to know. I've been working on precision agriculture for more than 20 years. And as a student, as a teacher, as a researcher, and as a farmer, I think, and again, this is just my personal comment in general, not for you, for everybody, who is using the word precision agriculture. There was and still is a big confusion on what is precision agriculture. This confusion, hopefully, was resolved in the European Conference of Precision Agriculture, which took place in Montpellier, France in 2019. This is where the official definition of precision agriculture by the International Society of Precision Agriculture, which is the most authoritative agency. So we have to disseminate the official definition of precision agriculture. It starts like that. Precision agriculture is a management strategy. I don't want to continue that. So let's make clear to those people what is precision agriculture before we ask them more. So again, this is just a personal comment that I kind of try to disseminate to my students, to the farmers, etc. Believe me, and I'm pretty sure you will agree, if you ask 10 people, what is precision agriculture? You might have 20 different definitions. Thank you.
Thank you very much for the comment, and I fully agree. I also met many people that they presented precision agriculture in different ways. So yeah, sometimes it's difficult.
Thank you very much. A small question, Mr. Polacek. You have some conclusions there. You have some conclusions. These conclusions derived from questionnaires or literature reviews, bibliography or so?
They were conducting direct questioning with 76 selected agricultures in Czechia, and also from secondary sources,
Research.
which means literature. Yeah.
Okay, thank you very much. Just to clarify
You're welcome.
This. Bye-bye. So let's keep going. Another telepresentation from Mrs. Sofia Anastasiadou from University of Western Macedonia, AI in Wildlife Rights and Ethics. Let's hear this. Ms. Sofia Anastasiadou. Sofia?
Yes, I'm here.
Okay.
Thank you very much. Let's share my entire screen. Okay, thank you very much. Well, my work is about AI in wildlife rights and ethics. As we know, machine learning, deep learning, neural networks, and artificial intelligence now could monitor ecosystems, record and protect the planet biodiversity, contribute to resource management and save energy resources, record the overfishing of the seas, the pollution of the wetlands, the behavior of wild animals, They record health professions and the illegal wildlife trade and identify the various species, etc. AI helps process a large amount of data related to wildlife monitoring, environmental DNA collections, and data analysis, nature of engaged species in an effort to preserve ecosystems. Thus, the aim of the study is to work, and of this work is to investigate the views of students on the use of technical intelligence in wildlife monitoring. For the purpose of the study, a research tool was developed which consists of 30 items which recorded the pros and cons of using machine learning algorithms to monitor wildlife. We use a 5-point Likert scale, and there were questions that capture the ethical and bioethical issues of wildlife monitoring through artificial intelligence. We have the sample consists of 428 responses that took part of the survey. You can see some demographic characteristics here concerning gender, age, year of studies, living places, school of science they follow. And also some more demographic characteristics such as income, mother education level, father education level, etc. Because the instrument was developed by me, a pilot study was carried out in order to see the reliability, to examine the reliability and validity of the scale, and to use, as far as the reliability concerns Cronbach alpha, the composite reliability and the average variance explain coefficients, and as far as the constant validity, principal component analysis was used in order to see if the conceptual construct we create was the same after the application of the PCA. The results show that there was a very good indices of reliability and validity. Thus, we conclude that we have a very reliable and valid instrument for our study. And this is more the results is the coefficients here and here. We use correspondence factor analysis in order to analyze our data. As you can see here, the characteristics roots and the factorial planes, the result of the first factorial planes, you can see in the quadrilates the opinions of the respondents. In order to be more precise, you can see here that the most significant variables regarding the first factorial level that persuade the post criteria name, inertia, contribution, and correlation are used in order the most significant items to be found. The first factorial level represents about 33 of the total inertia, and this is a very good percent. So we have here in the first quadrant, the group of responses, mainly age of 20 and 21 in the second year of studies, and they may be distinguished for their negative attitudes regarding the conceptual construct named AI positive impacts and AI negative impacts, and for their positive attitudes towards AI ethics. This is a very fundamental result because now students, they're not usually pay attention or the moral and the ethics of the impact of AI, not only in wildlife, but in our life, in everyday life also. On the second quadrant, we can see the group of respondents that may be distinguished for the positive attitudes regarding the conceptual construct named AI positive impacts and AI negative impacts in relations to monitoring wildlife life. In the four quadrant, the group of respondents may be distinguished for their neutral attitudes regarding the good effects, the good impacts of the use of AI in order to capture the way the wild animals lives. And this is the second factorial plane we can see here. Again, we have the roots of age and values, the characteristic roots, the percentage of the variance and the eigenvalues. And we can see here that the second factorial plane, it represents almost 30% of the total inertia, which also considered to be a very satisfying percentage. Thus, we can go to present the groups of respondents here that appear in the second factorial plane. In the first quadrant, we can see, again, group of responses, age 20, 21, in the second year of their studies, and they are not so aware about the impacts, negative or positive, about the monitoring of wildlife. On the second quadrant, we can see a group of responses who are they are very aware about the impacts of AI, and in the last four quadrant, we can distinguish the negative attitudes about the use of artificial intelligence and machine learning, etc., about the monitoring the wildlife. So, as far as the conclusions concern, we can see that the findings show that some demographic factors, such as age or year of studies, differentiate a little bit the respondents' opinion regarding the use of artificial intelligence in wildlife monitoring. The potential of AI to contribute to the sustainability of wildlife of the planet in general. There is no doubt about this, and there are bioethical dilemmas regarding whether we can interfere in such a way in order to monitoring wildlife. Also, AI technologies raise some special issues relating to the transparency of the algorithm, the bias of the decision, the ownership of the data they collect, and the process in which they develop their channeling models and drive decision making. And I think that more research needs to be done so that we can use, in order to know if and how we can use AI in order to have the sustainability of the planet, its ecosystem, and the protections of the fauna and the flora. Thank you very much.
Thank you very much, Mrs. Anastasiadou. Questions, please? Nobody?
Thank you very much.
Okay, thank you very much. Let's continue with an oral presentation from Mr. Ioannis Sotiriadis. He's from Aristotle University of Thessaloniki, and he will talk about a digital learning hub for future green and ethical leaders, a mapping of educational initiatives related to sustainability in higher educational institutes. Okay, Yannis, you may begin.
Okay, thank you. My name is Sotiriadis Ioannis. I am agronomist. I am PhD candidate at the Aristotle University of Thessaloniki, and today I will present to you a program, a European program, through which we can envision a more sustainable future, even in a higher education, focusing mainly on the basic principles and concept, of course, of the permaculture. The program is called, as you can see, Permalabs program. In this program, Permalabs participated 6 universities and institutions from 6 different countries from all over Europe, and with more details from Netherlands, Greece, Portugal, Poland, and Croatia. And before we start, I must inform you that the program is fairly new and still in development. That means that today I will present you only a small part of its progress so far, which is more about recording the current situation prevailing in higher education regarding the concept and integration of permaculture. Of course, in the near future, we expect more and very interesting results. Until then, let's focus on the current data. So today, we will look at the program as a digital learning cube, learning hub for future green and ethical leaders. And we will see the results carried out by mapping educational initiatives related to sustainability higher education institutions. I must mention that many authors participate to this writing by me taking on the presentation, the task of the presentation. Okay, let's now move on the main topic of today's presentation. Let's talk about the concept of permaculture. When we talk about the permaculture, we refer to a design system for human habitats which mimics the patterns and relations found in nature. Furthermore, the term of permaculture should be used when adhering to its inherent ethics and principles which guide the system towards benefiting life in all its forms. But okay, until now, I am expecting that you have the questions, many questions. For example, what the connection with today's reality? Or why are we talking about the permaculture and why it's so important and how does it relate to the rest of society and business? Today, the period in which we live, characterized by extreme changes, mainly in the labor market, while at the same time there is a global pressure to convert into ethical management practices, work, and in general mentality. So all of the business and the organizations should be ready for changes to lead to more environmentally, socially, economically, ethical paths. The consumer, from the other side, as we know, constantly more and more interested about the environmental and social impact of the product that they consume. And that means that business should be able to focus on this. But what about the role of higher education institutions? And how can we give a solution to what we mentioned above? We think that the answer is simple: by educating young people to have all the necessary supplies through university institutions. The first step towards more ethical business management is implemented already by innovative higher education institutions that want to prepare their students to be the future green and the future ethical leaders. In fact, the European institutions have been playing this role many times in the past, for example, in the period of crisis, and engage in efforts towards a socio-ecological transformation, utilizing methodologies of transformative education to enhance students' competence, knowledge, and ethics towards a more sustainable and resilient future. However, there is a little evidence of new concepts, approaches in academic syllabuses. In short, the problem and the need we described above, an attempt is made to find a solution through training and appropriate education. But most of the time, this is not enough, this is not innovative and does not adapt to current changes. So here it comes exactly the Permalab project. with envisioning a sustainable future in high education business departments inspired by permaculture design principles. In other words, it comes to improve, to correct, and to deal with all of the above, becoming a powerful tool in the educator's hand with the aim of improving learning progress. Research efforts for a place-based and experiential learning that will lead to a digital learning hub inspired by permaculture and focus mainly in 3 ethics. As you can see in the slide, people care, earth care, and fair share. Before moving on the presentation with the results, I should first again mention that the program is at a very early stage. So far, the mapping of the initiatives has been done, that qualitative research was done to conduct the results through interviews with experts and specific questionnaires. Now, responses from partner universities were gathered and analyzed with descriptive statistics and manual coding was conducted to foster in-depth content analysis. The codification consists of the following categories: type of activity of the initiative, challenges, opportunities, engagement of the other community partners, methodologies employed, and finally, the intended outcomes of the initiative. In this diagram, as you can see, we can see the number of initiatives per country where partner universities are based. As you can see, the most of the initiatives are found in Greece, Portugal, and Netherlands, with Poland and Croatia following on the mapping. However, all countries have a similar number of initiatives and that create a common base for all countries which participate in this program. Now, about the target groups of the initiatives. In the chart behind me, you can see that, in fact, more than half, 15% of the initiatives mapped in all the institutions are designed especially for students. The following target group, with about 30%, is a group of academics and teachers in terms of teaching training. Finally, 7 initiatives targeted community members to have wider impact. To this end, an initiative targets teachers is also providing training opportunities for teachers. Now, about the compatibility of the institutions' initiatives with permaculture ethics, we can see that the most of initiatives are linked to the permaculture ethic of care for the earth. Second, a large percentage of the initiatives identify with the ethic of care for the earth, for the people, and then, finally, 8 from the total initiatives deploy aspects of social economy, which is associated with the third permaculture ethic, that of fair share. Now, about the identification of the variety of methodologies and activities applied in each initiative, the participants in the research had the opportunity to choose more than one type describing their initiatives. The analysis indicates that workshops are the most common type of activity used. Formally, established study courses are less than 30% advocating on the need for a new approach and a new curriculum. However, there are many efforts to increase sustainability education concepts through different methodologies, such as research projects, lectures, informal training experience, etc. Now, in terms of the methodologies used by initiatives and their intended outcomes, the analysis highlights a wide range of methodologies used by sustainability initiatives with notable emphasis on interactive, experiential, and real-world learning methods. Open discussions and workshops are the most popular, followed by hands-on experience category used in 10 initiatives. They are those with more initiative and specialized features, such as the Miyagi method and the flipped classroom or MOOC method. The percentage reflects the adoption of innovative, and diverse teaching approaches is less frequent. Now, this is the last slide with a diagram. We can see the challenges and the opportunities. The most challenging issue that institutions face is the lack of participants and volunteers. It's a common challenge. Administrative issues come up as the second most important challenge, followed by the lack of funding support initiatives that fall outside the mainstream organization of the courses. About the opportunities, the upscaling of initiatives was pointed out in all countries, as well as teacher trainings, in terms of peer-to-peer learning and exchanges with an academic staff. Finally, and the conclusion, I will simply state that the integration of permaculture, ethics, and principles into higher education curricula is a significant opportunity. There is an obvious need to develop evidence-based resources for teaching staff, and we feel that creating a digital social space for interaction between different stakeholders would enhance peer-to-peer communication and, of course, collaboration. This is about references. This is the last slide. I must tell you again that the program is ongoing, and we expect more results, find solutions, and implement them. If you have more questions or general information, if you want general information or clarifications, you can contact with Mrs. Partalidou, the responsible professor of the program in Greece, or Mr. Dimitrios Vlachopoulos, the professor and the coordinator in the program in Europe. Thank you for your attention.
Thank you very much. I think the best is yet to come here. Questions? Nobody? Again? Yes?
Okay.
We can move on to the next, the last but not least presentation about openness in businesses, a case study of food businesses in Thessaly. Telepresentation from Mrs. Ioanna Grigoriou from University of West Attica. Δεν συνδέθηκε. So we are over. Thank you very much. It was a quick, good session with many questions. And
We are here for the afternoon session, session 5, environmental preferences. We have a lot of presentations here, so I welcome you here to this afternoon session. And let's start with the first one, which is through from distance. So, students' evaluation of vulnerabilities towards climate change by Professor Sofia Anastasiadou.
Thank you very much.
Hello, Sofia. How are you?
Hello. Very well. Thanks, Stratos.
Welcome. Please, the floor is yours.
Thank you very much. So the presentation is about students' evaluation regarding vulnerabilities in relation to the change of climate. Well, the effects of extreme weather events around the world are enormous and have an incredibly substantial impact on humanity. Recent extreme weather events demonstrate the effects of the climate changes from Europe to Asia, from Americas to Africa, from the North to South Poles to Australia, and recently here in Greece we have seen enormous impact, negative impact of the weather conditions and the climate change in central Greece, in Larissa, in Trikala, etc. All of these effects are both environmental and economic, social, and even more political. The risks from these effects include, among others, an impact on the human life. It's very important. These effects instead of natural disasters. However, the distribution of these disasters is not uniform. There are countries where disasters leave a big spot. Special mention the disaster here that occur in poverty countries. This result that the population of such areas, on the other hand, do not easily deal with natural disasters, and on the other hand, the possibility of recovery from the previous situation is minimized, making this population extremely variable. In these countries, drinking water is missing, the distribution of agriculture is great, and the lack of resources maximize the difficulties. Thus, the purpose of the study is to explore students towards the dimension of climate change and the degree of people's vulnerability towards it. The sample uses 316 Greek male and female students who participate in the studies. Here are some demographics of the students regarding gender, age, year of studies, living place, school of sciences they follow, their parents' income, their mother education, and also their father education, in order to see whether the socioeconomics parameters have an influence on their attitudes. Responses complete a purpose-built questionnaire including 5 demographic questions. The demographic questions you can see, and 30 questions regarding vulnerability to climate change during the previous academic year, the year 2023 and 2024. And this is the methodology we follow. We use the well-known method of analytic correspondence or correspondence factor analysis. And in order to analyze the data, we can see here in the first diagram the characteristics roots, the percentile of the variance and the eigenvalue of each factorial axis, and then we can see the two factorial axes, the two factorial planes that the first three factorial axes they create. And let's explain a little bit. In this factorial axis, we can see in each quadrant the opinions of the students, and we have the similarity of their opinions and this similarity create the whole group of the responses. So here we have the responses and according to their opinions, and here are some conclusions regarding the study. The results show that the factors affecting variability to organize climatic change concern access to resources, governance and management of climate change, natural disaster preventions, environmental protection policies in general, threats related to natural disasters, threats related to environmental harms. All these factors are very well understood by the students, as well as the risk posed by the change that we have to face now, the climate change. Also, there were some inequalities according to students' views that can lead not only to different sensitivity towards the dramatic effects of the climate change, but are an inhibiting factor in any equal access to resources, in access to food, clear water, education, and disaster relief policies. Finally, the education level is another factor that affects the response to climate changes. It also shapes the interest in environmental ethics that is constantly being discussed, and the development of which helps to understand the need to protect the environmental to the great extent. And it was obvious as the education level of the parents were higher, the most they concerned about all these effects of the climate changes on the environment, on the resources, on the related to food supplies, etc. Thank you very much.
Thank you very much, Professor Anastasiadou, for your excellent presentation. Please, any questions? No questions? Okay, climate change is present probably, and especially here in the islands, such issues are much more severe than other areas. Okay, thank you very much. We move to the next presentation, also through internet. Bicycle and cycling paths in Trikala City, citizens' attitudes and opinions. The paper will be presented by Georgios Kolkos from Aristotle University of Thessaloniki.
Okay.
Yes, hello, the floor is yours.
Yes, thank you. Do you see my screen?
Yes, yes, clear.
Okay, thank you very much. My name is Georgios Kolkos. I'm a postdoctoral researcher in the Faculty of Forestry and Natural Environment in the Aristotle University of Thessaloniki. And our research is titled Bicycle and Cycle Paths in Trikala City, Citizens' Attitudes and Opinions. Our scope was to understand citizens' attitudes toward cycling and the infrastructure supporting it, with the goal of informing future urban development strategies. Modern cities are considered as major consumers of energy and resources and are responsible for a significant share of greenhouse emissions, contributing to global environmental challenges. The need for urban strategies that reduce emissions and promote climate neutrality is more urgent than ever. Achieving zero emissions and resilient urbanization requires comprehensive planning to address the ongoing climate and energy crisis. Bicycles represent an eco-friendly, functional, and economical solution for urban mobility. They have the potential to replace motorized vehicles, especially for short-distance trips, which helps reduce traffic congestion and greenhouse emissions. Moreover, cycling promotes physical activity and contributes to creating safer and more friendly urban environment. In addition to being environmental beneficial, bicycles offer practical and economic advantages. They are an affordable mode of transportation that can improve the quality of life for city residents. They are silent, they require no fuel, and they produce no pollution. So we can say that they are an ideal choice for sustainable city living. The core objective of our study is to explore how citizens of Trikala perceive the use of bicycles and the existing cycling infrastructure. We seek to understand the factors that influence their decision to use bicycles. The key questions that our research aims to answer are how do citizens of Trikala feel about the current state of cycling infrastructure in the city? What factors encourage or discourage them from using bicycles for their daily commute? And what are the primary obstacles that prevent of cycling as a way of transportation? The city of Trikala is a medium-sized city in Thessaly's region of Greece, with a population exceeding 60,000 residents. One of the city's most notable features is its flat topography, which makes it well suited for bicycle transportation. This geographical advantage has the potential to position Trikala as a model for sustainable urban mobility in Greece. However, despite the potential, the city's bike lanes do not form a continuous network. This lack of cohesion in the cycling infrastructure means that cyclists often find themselves navigating gaps in the network, which can disturb their journeys and reduce the overall convenience and safety of using bicycles for daily transportation. The data collection took place between 2023 and 2024. We survived a total of 385 participants who were selected using a simple random sampling method. This approach ensured that every resident of Trikala had an equal chance of being included in the study, allowing us to gather a representative sample of the population. The survey included both bicycle users and non-users, which enabled us to compare the perspectives of those who regularly use bicycles with those who do not. We designed a structured questionnaire consisting of close-ended questions, and this format was chosen to facilitate clear responses that could be analyzed. The questionnaire covered several key areas, like the citizens' view on the safety and organization of the existing cycling paths, like the experiences with specific challenges related to infrastructure, such as incomplete markings, vehicles obstructing bike paths, and pedestrians crossings, and like whether they felt that the current network of cycling paths encourage bicycle use. This questionnaire was designed to explore both the experience of those who use bicycles daily and those who don't. The survey also collected demographic information from the participants. The data collected were analyzed using descriptive statistics to summarize and describe the responses. And in addition, we employed a binary logistic regression modeling in order to identify the factors that influence the citizens choosing to commute by bicycle. This model allowed us to explore the relationship between various independent variables, such as safety perceptions and demographic characteristics. Participants were asked whether they considered the existing network of cycling paths in the municipality to be safe and well organized. This question was essential in evaluating the public's confidence in the infrastructure ability to support cycling mode. To assess the participants were asked to assess the extent to which the existing infrastructure was being utilized, and if they had used any of the road exits of the current cycling network. This question helped us to understand how widespread the use of the infrastructure was and whether there were barriers preventing a more frequent use. One of the key challenges facing cyclists is the quality of the infrastructure. So for this, we asked the participants to identify the primary problems they faced, like pedestrian crossing, incomplete, unclear markings, vehicles obstructing the cycling path, general malfunctions or poor maintenance, and crossing intersections. These responses provided valuable insight the specific areas where needed improvements. To continue, participants were also asked if they believe that the existing network favored or encouraged bicycle use. This is a crucial question for understanding the psychological and practical barriers that might prevent citizens from choosing cycling as a transport option. To better understand how different groups of people use cycling infrastructure, we also collected the demographic information. The data from these questions were then used in our binary logistic regression model to explore which variables are most influence for a participant in order to use a bicycle. I now proceed to the results of our research. Here we can see the percentage of use of a bicycle to commute by gender. It is seen that female respondents are using more frequently via bicycle to commute than males. And in addition, it is seen that younger respondents, those between aged 18 to 30, are using more frequent a bicycle in comparison with other age categories. According to our results, a slight higher percentage of female respondents, which was 53%, consider the cycling paths to be safe and organized compared to male respondents, of whom only 45% share this view. It's important to highlight that only around half of both men and women consider the cycling network fully sufficient. These results emphasize that the need for further improvements, especially for male users, who appear to be more skeptical of current infrastructure. Moving on the perceptions on the by age group, as you can see on the right side of the presentation, younger respondents, particularly those aged between 18 to 30, were the most positive about the cycling infrastructure, with around 50% of them indicating that they found the cycling paths safe and organized. Turning now to the overall rate of bicycle use for transportation, the left figure shows a significant finding that only 29% of the respondents use bicycles, while a vast majority do not use. This reveals that despite the potential for cycling to become a more popular mode of transport in Trikala, most citizens still rely on other means for transportation. The three figures on the right side demonstrate the demographic breakdown of the respondents in terms of gender, age, and educational level. Our results showed that the younger respondents and those with higher educational backgrounds are more likely to use bicycle for their daily transportation. Here we show the results of our binary logistic regression model that we implemented in SPSS software. The regression analysis identified several key variables that affect the likelihood of choosing cycling as a mode of transport. These are represented by their p-values and odds ratios, which allow us to analyze the strength and directions of their influence. Regarding the pedestrian crossings, the negative coefficient indicates that those who face difficulties with pedestrian crossings are much less likely to cycle. In addition, respondents who reported issues with incomplete markings on cycle paths were significantly less likely to cycle. These factors regarding vehicles obstructing cycle paths, suggesting that while not as strong as other factors, the presence of vehicles in cycle lanes does reduce the likelihood of bicycle use. The analysis showed also that respondents who encounter malfunction, such as broken or uneven cycling paths, were actually more likely to continue cycling despite this. This could indicate that more experienced or committed users are resilient in the face of infrastructure problems, although these issues still need to be addressed to attract new users. Finally, education was a critical factor as university graduates and those with higher education were more likely to cycle. This suggests that the educational level plays a significant role in shaping attitudes, with higher education correlating positive with bicycle use. To conclude, our study highlights several key findings about cycling behavior and infrastructure in Trikala. The main takeaway is that although the city has great potential for cycling due to its flat terrain, a large portion of the population does not yet use bicycles for their daily transport. Several factors were identified as barriers. At first, incomplete or poorly marked cycling paths, as many respondents reported problems such as incomplete markings or vehicles obstructing lanes. Secondly, perceptions of safety, particularly at intersection and pedestrian crossings, were common issues. And finally, there was demographic disparities. Younger individuals and those with higher educational backgrounds are more likely to cycle, which suggests a need to make improvements to make cycling more appealing to a broader demographic range. Our findings emphasize the importance of improving cycling infrastructure to encourage more residents to adopt bicycles as a primary mode of transportation, addressing the gaps in the existing network, increasing safety at key points like intersection, and rising public awareness could increase bicycle use in cities like Trikala. By doing so, the cities can move closer to achieving their goals for sustainable urban mobility, reduce traffic congestion, and promote healthier lifestyles among their citizens. That is all. Thank you very much for your attention.
Thank you very much. Any questions, please? Nobody cycling? I want to ask something, a non-technical question, very simple one. Do you know what is the share of the population of Trikala that uses bicycle?
I think it's around 30%. It's a very high. It's a very high percentage if we see other Greek cities. But Trikala is an ideal city for cycling. They have a flat terrain and it's a very, there are many potential to increase this percentage.
Yes, yes. Also, it would be interesting if we could see data about, let's say, a time series showing the share of people that are using bicycle through the years. Does it increasing? Is it an upwards trend or not? Because this would, let's say, show that your results are okay, since you said that young people are more fond to use bicycle. Through the years, the trend is increasing or decreasing?
There wasn't such a research in our study, but I couldn't agree more with you that I believe that Trikala, the percentage of bicycle users was raised among the years. Nowadays, younger people, they see bicycle as a mean of transportation that it has no cost and no fuel. And if we give them the right infrastructure, the percentage can be raised even more.
Okay, thank you very much.
Thank you.
We move to the next presentation, an interesting presentation by Professor Kontogiorgos from International University. He is here. An investigation of farmers' perceptions on the complexity of and effectiveness of organic product certification standards.
Hello, everyone. Nice to be here with you. I will present our work about the investigation of farmers' perceptions for the certification for organic product. Briefly, the contents of my presentation, introduction, methodology, results, and conclusions. As an introduction, I can say that public awareness of environmental protection and the demand for pesticide-free, healthy food are driving the growth of organic farming sector, and consumers are willing to pay a premium for organic products, fueling this expansion of organic production. In the European Union, organic certification is based on the concept of a third-party certification. That means a company with some procedures make an investigation, inspection, and certifies that the production is accomplishing some rules. This certification could be used as a reliable monitoring system for organic production. It could also reduce the information asymmetry between organic producer and consumers. Anyway, we have to explore farmers' perception about this complexity and the effectiveness of organic certification standard, as it can increase the adoption of organic farming, but also can give us reasons why some of our farmers quit organic farming. So, in this research, we have three main research objectives. First, to identify attitudes of organic farmers participating in this survey, to identify perceptions about the complexity, and also identify perceptions about the effectiveness of the organic production among the Greek farmers. Our methodology: we used a questionnaire survey the previous year. We used a simple random sampling procedure to find organic farmers based on a client's list of a certification company. We used a questionnaire that was filled through interviews from farmers. We had 100 fully completed questionnaires. That's quite a big number from farmers. And we used this sample to make our analysis about the perceptions and finally to reach some conclusions. Our results: 100 farmers. Okay, the areas where the private company giving these certifications is used. So we have 7 prefectures in Greece that we have 100 farmers. Some demographics for them: 60% are from 40 to 60 years old. Almost 40% of them have 10 to 30 years farming experience. Almost 60% are up to high school education, that is 12 years of education. 40% of them are exclusively farmers, that they have no other source of income, and there are 53 of them are men. Another important demographic data is that we used if they are exclusively organic farmers or if they are both organic and conventional production farmers. We can describe better our sample by using a different grouping method, saying that farmers that are started as organic and remain organic, and we have another group of farmers started as conventional and turned to organic production exclusively, and farmers started as conventional and have still both organic and conventional production. For the first research objective, we try to find out motives to adopt organic farming. We have 3 main categories. We use the principal component analysis to find out which is the main motives to adopt certified organic farming. The first group is to protect consumers' health, to produce healthy, safety products, and to protect, in general, the environment. This is the first group. The second group is the easy trading of organic products, the increasing demand for organic products, and the higher prices for organic products. This is the second factor. The third one is protecting farmers' income and, by using EU subsidies. That is an important economic factor. And we finally find 3 factors, 3 groups of motives to adopt organic farming. The second question that we investigate is difficulties in adopting a certified organic farming. We have 2 factors, not so statistically significant factor analysis, only 52% of total variance explained. Anyway, can give 2 groups, 2 factors of difficulties. The first one is the high prices of organic products as a low demand for these products. insufficient technical support to support the procedures and the whole organic production, the production cost for organic products, and the low subsidies amounts. And the second factor, the second group of difficulties is the certification cost and the procedures to move to organic production and low yields for the organic production, the low output of the production. So we have two groups of motives, two groups of difficulties, and three groups of motives to adopt organic farming. For the second objective, to find the complexity of certification process, we used two simple questions to find the perceptions of farmers. How difficult is to follow the certification procedure for farmers? Now, based to the three groups of farmers, turned to organic, conventional organic, and organic, we can see that the majority of farmers agree that it's difficult or very difficult to follow these procedures. So you can have an image that it's a little bit confusing procedure for farmers. The second question that we asked for farmers is, what do you think about record keeping for certification? We had three possible answers. It's a typical obligation, is to help certification company or to help farmers. We can see that the sample is divided, and half of them almost say that is a typical obligation, and the other says to help farmers. It's interesting to see that the group of conventional and organic farming says that this record keeping can help farmers. The other one says that it's only typical obligation. The third part, about the effectiveness. We have two questions. A statement about the requirements of a certification, if it is oriented for production effectiveness or oriented to certification effectiveness, if it helps production or it helps the certification body to make their jobs in order to give the certification. Again, here, the farmer says for all groups that these requirements are more to help companies in order to issue this certification. This is almost 65% for all groups. The second question about the effectiveness of certification is to characterize their compliance with the certification requirements. It's interesting to see here that no one states that is an excellent, it's very low percentage. Majority of them says it's satisfying, and on average says a lower percentage, about 30%. It's interesting to see that organic, pure organic producers says almost half of them that their compliance is almost 50%, 43%. So the majority of organic farmers says that they have an average compliance with the certification requirements. So for our conclusions, main motives to adopt organic farming: protect environment and consumer health, take advantage of organic production trading, and protect farmers' income. As main difficulties are the insufficient support, lower than expected market penetration, and procedures and certification requirements to move to organic farming. Certification procedures are very difficult to follow for all farmers. Record keeping is recognized as helpful tool only by farmers that are involved in both conventional farming and organic farming. And other groups of farmers in this survey believe that the record keeping is only for typical reasons. And about the effectiveness, the efficiency of certification process, compliance is characterized by all farmers just as satisfying, and the certification requirements are oriented to ensure certification process in a formalism way. So as some recommendation, very important is to simplify certification procedures, and the next one is to provide training on the certification requirements and the procedures in order to move to the organic farming. We have to say, as limitations, that these conclusions are based only on the perception of those who participate in this survey. These findings are only indicative, and further research with a proper sampling procedure is needed in order to have more accurate results. Thank you for your attention. Any questions?
Thank you very much, Professor Kotoyorgos. Any questions? Yes, please.
Do you see any role for digital technologies in lowering the certification burden, the record keeping for organic agriculture?
Sorry, once more.
Do you see a role? Do you see a role for digital technologies in lowering the burden for organic farmers in terms of record keeping, recertification, or anything like that? Is there anything in your interaction with them which would indicate that?
As a tool to make them
to make it easier.
Probably. Sorry. Probably. Technology could help record keeping and procedures. But again, for farmers, they have to complete all these required record-keeping procedures in a different way. So probably their work will be lower, less, but they have still to do all of this work. Probably there must be a combination of reducing the workload by technology and reducing requirements and make them more simple.
Okay, thank you. Maybe for farmers, technology and makes things more difficult for farmers, technology. Maybe. Though farmers that they choose to go organic are more usually educated and more keen to technology.
A motive to move to organic is economic motives. So
not only.
It's not always well educated. Some of them see an opportunity to make some more money. That's why there is a motive for some of them not to be so organic.
Any other questions, please? Okay, thank you very much.
Thank you.
We move to the next presentation is by Professor Stavros Valsamidis from International University. His study entitled Pro-Environmental versus Anti-Environmental Perceptions. Is Stavros online?
Unfortunately, I'm in Kavala. I didn't have the chance to come to Samos, to the beautiful island of Samos. But I will try to present our conference paper. How much time do I have, Mr. Chairman?
10 minutes.
10 minutes.
Professor
Thank you very
Valsamidis.
much.
Okay, can you share your presentation also?
Yes, I will do.
Okay, thank you.
Welcome. So, this is the paper. My colleagues, Yanula Floro, Athanasios Mandilas, Sofia Anastasiadou, who is also in this conference virtually. Me, Stavros Valsamidis, we contribute to this paper. This is the table of contents, which are the reasons behind this dilemma, the purpose of the research, the theories and approaches now, the methodology used, the results, and conclusions and implications. The reasons behind the dilemma is climate change, of course. Climate change nowadays is more than obvious. Greenhouse gases, waste, industrial and nuclear burning of fossil fuels have changed the climate to an excessive degree and with unpleasant consequences. The second reason is the direct changes in nature. Direct impacts include melting Arctic ice, rising temperatures, extreme weather and flooding, and rising sea levels. The human action, of course, is guilty for many of these consequences. Human activities that have caused climate change have consequences for ecosystems and natural wealth, fish reduction, agriculture, and livestock, of course, the health, the nutrition, and food, the biodiversity, the climate, the clean water, and it supplies the clean atmosphere, economy, society, and many reasons. So we have two approaches. One is the anthropocentric, which is a human-centered view, and the other is biocentric, which is the non-human-centered view, the ecocentric. Of course, there are theories and approaches, not now, but not only now, but many years ago. The major of these are the anthropocentrism, the biocentrism, the humanitarian approach, the non-humanitarian approach, the theory of ecological attitudes. So there are approaches where one is the humanistic approach, which focuses on the value of biodiversity for the people who enjoy it or experience as participants in it and benefit in various ways. And the opposite dimension is the non-humanitarian approach, which refers to the value of biodiversity per se. The ecocentrism is considered to be the view that non-human beings, things, and nature as a whole have intrinsic value, and this value is which one thing does not contribute to the value of another. We will use the last theory, the theory of ecological attitudes, which suggests that individuals that appear to share preservation attitudes in the framework of biocentric attitudes do not inevitably share anemic utilization in the framework of the anthropocentric attitudes. So the purpose of this research is to investigate the environmental attitudes of students of 3 countries, Latvia, Greece, and the Netherlands, based on the theory of ecological attitude. Of course, it's common sense that we use Greece. The other countries were selected as a convenient sample, since we had Erasmus students who could contribute to this research. So, as we mentioned earlier, there are the two main and contradictory, of course, terms: the preservation and utilization, which were assessed with multi-item measures. For preservation, we used intent of support, the intent of support, the care of resources, the care for resources, the enjoyment of nature. Intent of support had 3 items, 3 questions actually. The care for resources, which consists of 3 items, and the enjoyment of nature, which consists of 3 items. On the other hand, the utilization used 2 items, used the altering nature with 4 items, 4 questions actually, and the dominance over nature with 3 items. We used the 5-point Likert scale, where 1 indicates strongly disagree, and 5 indicates strongly agree. The research hypothesis, we use the research hypothesis that there is no correlation between preservation and demographic factors. And the positive one is that there is a positive hypothesis relationship between preservation and demographic factors of the 3 countries. So this is for preservation. And similar hypothesis for utilization. There is no correlation between utilization and demographic factors, and there is a positive hypothesis, the second one, between utilization and demographic factors of the three countries. If we move to results, first of all, according to demographic characteristics, the country of origin, we see the frequency and the percentage in this table. We see also the frequency and percentages for gender. Of course, four of them preferred not to say about their gender. And the socio-demographic characteristics for their age, frequency and the percentages respectively. Most of them, of course, because they are students, are very young, and we see the ratios, the distribution of the sample. So we see the results. We actually have portrayed in this table the questions and how many answered to each question. It is this is the preservation questions, and the corresponding utilization questions. We see the constructs of these questions, of these factors, and we resulted to this component matrix. We use factorial analysis where the variables that are mainly separated on the first axis, negative and positive coefficients with axis 1, and these are highlighted with blue in the first axis. We have the second axis, of course, and the third axis. We have actually 4 components. We see this slide, the total variance explained with the initial eigenvalues and the extraction types of squared loadings. We see the contribution of each component, each axis. We see the 25, almost 25% of the first, 11% of the second, 8% of the third, 6%, more than 6%, or approximately 6.889. And we checked the sample for the adequacy. We used the well-known Kaiser-Meyer-Orkin measure and Bartlett's test, and we see that we see the results. The summary of the questionnaire about biocentric, there are 8 questions. How many answered positive? 822 negative, 341 neutral, 304, and 9 questions for anthropogenic positive 374, negative 583, and neutral 347. In this slide, we observe the correlation between gender and preservation. We see that the 9 items regarding preservation were correlated with the gender, and there is no difference. There's no difference since the significance of chi-square is greater than 0.05, and there is no correlation. The same about the gender and utilization. We also observe that there is no difference since the significance is for chi-square is greater than 0.05, and this is about the gender. About age, age is a quantitative variable, and the correlation is calculated positive in one and negative in the other. And we see this this efficiency. About the country of origin, this is a major difference. We have a difference here because the significance in chi-square is less than 0.05 about the countries. And we can summarize here for the three countries regarding the financial support for natural protection. We see in Greece is high support, in Latvia high support, in Netherlands, the Netherlands neutral. The promotion of nature's importance is moderate for Greece, proactive for Latvia. For the Netherlands, it's moderate, plus, and the intrinsic value of living things, it is high recognition for Greece, for Latvia, and for Netherlands. The conservation practices for energy and water in Greece is moderate. For Latvia, it's high engagement. For the Netherlands, it's a high engagement. The preference for natural environments in Greece is a high interest. In Latvia, is high interest also, and for Netherlands is high interest minus. And the enjoyment of nature's quietness for Greece is high. For Latvia is high plus, and for Netherlands, the Netherlands is high minus. About the country of origin and utilization, we also observe that there is a difference since the significance is in the chi-square is less than 0.05, and we see this the degrees of freedom and the significance, as we mentioned earlier. And the same, the similar or the same, not the same, the similar slide regarding the utilization of the country of origin. We also see the differences. I try to speed up. We have mentioned all this in detail in the paper, the short paper, and the results, the differences in utilization and preservation attitudes among the three countries, attitude toward natural modification, prioritization of human needs versus environmental conservation, support for agricultural expansion and land use changes, dominion over natural versus intrinsic value recognition, economic development versus environmental protection, and conservation practices and awareness. We see here the well-known method of thicogram, or to others box plot. It's a convenient way to depict the numeric data in observations. We see here among the difference among the three countries, Latvia seems to be normal. Greece in utilization has extreme values, and Netherlands follows. And of course, we draw the conclusions and the implications. The utilization, the preservation attitudes may appear to be contradictory. It is possible for individuals and societies to hold both simultaneously. Students may have either a biocentric pre-environmental or a human-centered anti-environmental perception, but not at the same time. This is the first point. Students treat biocentrism, preservation, and anthropocentrism utilization as separate and not necessarily relevant features of environmental perception. a balanced approach that integrates both viewpoints of anthropocentric and biocentric perspectives is essential for fostering environmental sustainability and ensuring the long-term health and resilience of our planet. Students also believed that although it is certainly understandable that one would have a high rating for conservation, indicating strong desire to protect the environment, but at the same time claimed that the primary purpose of the environment is to benefit people, also resulting in a high score of the utilization factor. And in the end, we see in this scale the differences from Latvia to Greece, and no countries in the bubble. Future research may expand the aim of the issue to other countries and different cultures, different environmental policies, different industrial, more especially tourism and hotel industrial development. Of course, new technologies such as big data applications, pipeline, dynamic scheduling of big data streams, and new technologies can offer and assist to gather and analyze amount of data related to tertiary university students. Some of the references we used. Thank you very much for your attention.
Thank you very much, Professor Valsamidis. Any questions, please? Okay, thank you very much. No questions. Let's move to the next one, which is also through distance. It's by Professor Kalazarba from the University of Catania, Italy, an evaluative approach of corporate sustainability in agri-food systems.
Yes. Do you hear me?
Yes, can hear you. Hello.
Oh, okay. The volume for me, it's not that well. I hear you low, that's why. But as long as you hear me, it's okay.
Okay.
Now it's better. Yeah, thank you. Thank you very much.
Okay, thank you. Can we see the presentation, please? Can you share it?
Sure, sure. Is it okay?
Yes, okay. Thank you very much. The floor is yours.
So, good morning, good afternoon to everybody. First of all, I would like to thank the organization to accept because they accepted our contribution. And another thing that I want to highlight is the fact that this research is in progress, and it's like the funding source is an RPP project called On Food. So the title of our research is an evaluative approach of corporate sustainability in the agri-food system. And there are other professors that are collaborating with me, which are Professoressa Storiale, and Dr. Camarata, Professor Matarazzo, and Professor Scuderi. We all are from the University of Catania. I cannot go. Okay, so the research structure of this analysis basically comprehends mainly two objects, which are the analysis of the implementation of the level of corporate sustainability into the agri-food system, doing some interview to agribusiness enterprises, and the analysis of the related level of communication to stakeholders involved in the environment. The methodology that we used is based on an integrated approach, which include a quantitative and a qualitative perspective.
The assumption is that firms, as well as all the actors and stakeholders involved in the environment, are they participate to the socioeconomic growth process of the economic system worldwide, and nowadays more than ever are called upon to take responsibility for the negative externality that they produce as a result of their production process. Well, the integration of the circular economy or green economy approaches in the agri-food system, it's something that is considered by policymakers a strategy that is necessary to move and to make a transformative progression and to address some future challenges that are on the cornerstone of the policymaker goals. So now we can say that for decades, there has been a real and actual try by firms and actors involved to make a shift in what is the business management from a conventional approach, which is a linear economy, to a circular approach, which it's more aligned to sustainable principle. Yes, basically, if that is what happened until now, we can say that the state of art now it's pushing a little bit, because it's now a fact that the directive about corporate sustainability and the due diligence requested is like now active. It's promulgated by the European Union Parliament, and the goals of this directive is to foster sustainable and responsible corporate behavior in all the companies and business process, and that involve every kind of business and every kind of productivity process, and also, of course, the agri-food business. It's also aimed to address not only economic growth, but the three dimensions of the sustainability. So the ethic one, which include the human rights, and the environmental dimension. So as I said before, our research is actually in progress. The methodology that we structured, we represented here like the goal that I already anticipated, and I said that it's about integrate approach between a quantitative and a qualitative analysis, and I'm going to explain more in detail. Well, about the quantitative analysis, it will regard the study of a specific website of Italian agri-food firms, to see how is the level of the implementation of the corporate sustainability in their productive process. To do that, we use what we call the 7S model. The 7S model is articulated in 7 evaluation criteria that I'm going to show you. Each one of these criteria evaluate a specific and particular aspect of the corporate sustainability. And about the qualitative phase, we are going to develop some focus groups, like with the manager of agri-food business. Yes, and the goal it will be to acquire specific information about all the motivation that are behind their choices to go through an alignment to the corporate sustainability standards, but also to find out potential problem connected to the adoption, to the actual adoption to corporate sustainability and innovation. So basically, we want to highlight potential strengths and weaknesses to be useful for firms, of course, for stakeholders, but also for policymakers. This is the expectation. So after we will be holding these kind of focus groups. We will elaborate the data with the theory of planet behavior, which, as you, I'm sure, all well known, is a theoretical framework that for systematic study that study the factor that influence the human behavior. So in this case, the assumption is that the decision to take a particular action is directly related to individuals' behavior and intention. And this behavior and intention is assumed that is influenced by three factors. These three factors are the attitude, the subjective norms, and the perceived behavior control. So, as I said before, I will have pointed out better the 7 criteria that we were going to use to basically investigate all the dimension of the sustainability, so the social, the economic, and environmental, which incorporate diverse aspects while investigating an economic productive process. So each one of these criteria aim to find out more about the level of corporate sustainability adoption and implementation of these firms. Of course, one of the problem that could arise is the fact that in this moment, not a lot of firms share this kind of information. But as I said before, the directive is it's something very new, so it was promulgated this year. So it's a very innovative subject. So we are very excited about that. So the expected results will be so yes, the data will help us to describe a specific framework, and so we will make a comparison to all the websites that we will be able to analyze and to study in order to highlight some key drivers to identify the motivation that push all the managers to implement and improve this corporate sustainability. And also we want to try to find out, while speaking with them, some potential short and long-term actions and strategy to better develop this new dimension of the sustainability. So thank you very much for your attention.
Thank you very much.
Thank you.
Any questions, please? No questions? Okay, thank you very much for your contribution.
Thank you. Thank you very much.
Okay, we can move to the next one.
Yes, thank you.
Okay, the next one is by Professor Anastasiadou, assessing students' perceptions and attitudes towards wildlife by PCA analysis and implicative statistical analysis. Sofia is online.
Hello. Thank you very much. Hello again.
Hello. Yes, the floor is yours.
Yes. Thank you very much. This is another topic for the wildlife. Wildlife has always been of everything to man because it aid him in his own subsistence and conceptual survival and as a means of acquiring health. The tracking, killing, or even exploitation of wild animals, both for exploitation and for the far skin state and for their use. For years now, people demand for land, sea, drinking water, and those all elements have been an important priority. However, these demands have had a huge impact on the climate and the stability of wildlife. But the need for the stability of wildlife is more evident than ever before as climate change and this effect have been released the hard way. Floods, fires, global warming, and disasters are now more than evident. A signal point concerns that wildlife can pose a threat to human life, both from attacks by wild animals, destruction of pastures and crops, as well as their transport, even fatal ones, which could lead to new human diseases, which can take an extent of a pandemic. Essentially, there was a need to control the wildlife population. Transsexual ethics and animal ethics are nowadays widely accepted. That's why we made this study in order to investigate and evaluate students' perception and attitudes towards wildlife. For the survey aims, a questionnaire was released that explored the views and attitudes of students about wildlife. The questionnaire consists of 4 conceptual constructs which concerns wildlife damage management and includes questions exploring the right of farmers to protect their property, wildlife damage management, etc. The second conceptual construct concerns the necessity of wildlife population control, and we have questions that explore the necessity of such control. The third conceptual constraint is related to values of protecting wildlife and wildlife nature that includes questions that express concern about the protection of wild animals and ecosystems, as well as the importance of all species and the value of animals' welfare. And finally, the last conceptual construct is about the protection and the sustainability of the environment and includes questions relating to policies and action for the protections of wild nature. We ran a pilot study of 50 students in order to assess the reliability and validity of the new measurements tools. And then we ran a final study with a sample of 322 Greek students from various university departments and faculties, and those students participate in our study. Those students were from the University of Western Macedonia in Greece and the University of Naples, Paphos, after the relevant permission. All the questions were completed electronically. And here are some demographic characteristics about the sample of the students. We can see gender, age, year of studies, living place, school of studies, income of the family, education regarding the mother's level, and the education level gathers regarding the father of the students. As far as the pilot study concerned, here we have the global alpha and composite reliability and average variant explain, all regarding the whole scale and regarding the conceptual constructs of of this scale. All the indices were acceptable, indicated that we have a valid questionnaire. And here we ran a factor analysis and implicative analysis in order to analyze the data, and I will present some results. Those results show that the male and female students of our sample understand the need to protect wildlife and they environment with all its recognize the wildlife damage management and includes questions damagements. They recognize the values of protecting wildlife and the wild nature and pay attention on the protection and stability of the environment. And finally, they recognize the value of environmental ethics. I'm making it short because I saw the time is running. So thank you very much for the attention.
Thank you very much. I think it's better to proceed to the next presentation, Sophia, and then to ask if there are any questions. Okay. The next presentation is about preserving student knowledge and attitude biodiversity conservation, a multi-level statistical analysis. Okay.
Okay. This is all about the diversity regarding the perception of students. Yes. Is it okay now?
Not yet.
I made it again.
Just a moment.
Is it all right now?
Yes, okay, thank you very much.
Okay, thank you. So, biodiversity is extremely important for the preservation of ecosystems, the viability of all living organisms, and the protection of the planet. It contributes both to the maintenance of the food chains and the sustainable use of natural resources, the preservation of all living organisms and forests, the deforestation of which a huge impact on climate change, environmental pollution, agriculture, livestock, public health, and economic well-being. The biodiversity crisis has reached an unprecedented level. Natural disasters in habitats, ecosystem, and are irreversible, just as climate change and environmental pollution are also irreversible. It shows how important the role of education and teachers in order for students to learn the importance and value preserving the biodiversity, which played such an important role in the lives of our society, as well as the future generations. Teachers are the ones who who show the direction to students and make students aware of the need of preserve biodiversity. They are the ones who will highlight the impact of the effects of human activities on biodiversity across the planet. They are also the ones who call up to contribute to the formation of educational policies as well as curricula which will aim to the preservation of all life forms and ecosystems as well as their care for all the ecosystems of the planet. Thus, the aim of the work is to investigate teachers' attitudes and beliefs regarding the conservation of biodiversity. Here are some demographics of our sample. We have 218 teachers. They asked to fill in a questionnaire of a 5-point liter scale. We can see here some demographics concerning the gender, age, working years, place of school, and education level. And we use multivariate statistical analysis in order to analyze the data. In particular, we use implicative statistical analysis, and here we can see in the right place of the presentation the hierarchical tree, and in the left place the similarity tree, and we see that all the opinions are grouped in a similarity diagram and show that there are strong relations and strongly as strong are the teachers' attitudes. In the hierarchical tree, you can see which one is the leader of the opinions of the respondents. And here we have the implicative diagram. We can see here that we have a 90% significant of the relations between the items, and here we have also the percentage as far as the respondents' answers concern. We can see here from the percentage that every percent, it's almost every percent, it's up to 90%. That means that their opinion are very strong regarding the necessity to take measures about the biodiversity. And here are some results and conclusions. The results of the diagram shows that there is a positive attitude towards the preservation of biodiversity, the need to protect the environment, the preservation of energy resources, and the ecological consequences. The consequences of human actions of the environment are thoroughly discussed by the students, and as we can see, we previously see from the answers, they claim that educational programs can change the attitude of pupils and students towards the preservation of the ecosystems and take actions in order to care towards the environment in general. According to the results, it's very important that pupils and students, who are the hope of future generation, to contribute with many actions in order that the environment to be protected. They also claim that artificial intelligence can contribute to know how the organization, every organism can develop and how to support their sustainability. Thank you very much again.
Thank you very much. Okay, thanks. Any questions, please? No. So, Sophia, our students are sensitive for biodiversity issues?
Yes, yes, indeed. They are very sensitive.
Okay.
They care about the climate change, the biodiversity. I think that the last events regarding the disasters in Greece make them be more aware than ever before.
Yeah, yes, these issues, okay, yes, it's true that make them to become more interested in environmental issues.
Yes.
Okay, thank you very much, Professor
Thank you very much.
Anastasiadou. We move on. Next presentation is again through distance. It's by Antonios Tabakis from Democritus University. Residents' views and perceptions for the use and design of the urban green infrastructure to the second largest municipality of the metropolitan area of Thessaloniki. Mr. Tabakis.
Hello. The paper is about the residents' views and perceptions for the use and design of urban green infrastructure to the largest municipality of the metropolitan area of Thessaloniki. The urban green infrastructure is a network of urban green spaces such as parks, productive landscapes, gardens, green corridors, and roofs, and contribute to the biodiversity conservations and benefit the people of Thessaloniki through the maintenance and enhancement of ecosystem services. The urban green area is an indicator of sustainability for the city and addresses the needs of the people that are reflected in the development and the policy of the city concerning this infrastructure. The study evaluates the views and perceptions of the local residents for the use, design, and the design of the urban green infrastructure about the area of the particular municipality. The paper is organized in 3 sections. The first evaluates the residence quality of the urban green infrastructure, the frequency and the durations the residents visit the parks and the other infrastructure. The second section presents the design of green spaces and the meaning of the maintenance of a natural landscape to the design and construction of an artificial landscape that make the users feel closer to nature and the environmental art. This research was conducted using personal interviews. The questionnaire developed for the purpose of this study consisted of 15 questions. Those questions were addressed to the household of the local community and that consists the second largest municipality of Thessaloniki. The green infrastructure of the municipality of Kalamaria covers 635 square meters and accounts for about 10% of the total area. The data was collected in 2020 in the months of May and July. The applied sampling involved a list of domestic electricity consumers, and the households were randomly chosen using random numbers. The size of the sample was 1,567 households, according to the simple random sampling formula. Hierarchical log linear analysis was used to examine 4 groups of variables prior to the application of the hierarchical log linear analysis and to check the independence. The expected frequency in the contingency table were examined. Classes were grouped together in order to satisfy the criteria mentioned by Tabachik and Fidel. Now you see the area of the research, that is the municipality. Concerning the results, the respondents that took the survey were almost equally divided between men and women, with ages 18 to 30 being 35%, with 34% of the respondents being highly educated, 44% of them were married, and 44% of them had children. Most of them, about 24%, were private employees with income ranging from 10,000 to 20,000 euros. The use of the urban green infrastructure were evaluated by the residents of the municipality by the frequency, the duration, and the preferences of the individual. It was found that 45% of the residents were of the opinion that the infrastructure was of mediocre quality, and 24% considered it good to very good, very good. With regards to the frequency of visits, the residents evaluated the urban green infrastructure at the municipality and visited the infrastructure about 25% once per week, about 25% visited once a month, 40% don't visit very frequently, and 0.3% didn't answer the question. The duration of the visits of the residents is about 25 minutes. while about 40% visit for more than that. And 5% of the respondents didn't answer the particular question. A previous study conducted by Karanicola in 2014, 10 years earlier, in the same municipality, showed the residents visit green areas rarely, but spend a considerable amount there, with 45% of the population affirming that their visits last for more than 55 minutes, while 41% of them spend less time for visiting parks. Besides, the residents usually visit parks and green infrastructure alone, while 50% of the visit the parks with a friend or mate, and 15% visit exclusively with friends and other relatives. Afterwards, the second part of the study, the residents were asked to answer the questions and choose between two figures that depict two different kinds of benches. Those particular benches are the one in the left that encourages connections between visitors and speaks to greater connection to other people that visit the park, and the one in the left, the one in the right, that prevents connections and is exclusively for people that don't want to speak to other people in their visit and want some kind of isolation. The hierarchical rock analysis was implemented for the variables bench with aim, the landscape of the city, the design of green spaces determined from. There was no interaction between these three criteria because the chi-square of Pearson test is 4.697 with probability of 0.96. And because the Hill-Likely calculation is 4.789 with probability of 0.91. This represents the following. The residents choose benches that on which they come in with other people, they find the landscape more artificial. On the contrary, they choose benches with loneliness as preferable and the landscape of the city more natural or more artificial in some balance. The residents prefer the design of green spaces with a simplicity and consider the landscape of the city as more natural or natural and artificial in balance. The design of the urban green infrastructure, according to Kailidis, when we design green spaces, we pass from meaning of maintain of a natural landscape to designing and constructing an artificial landscape that makes the user feel closer to nature and useful environment. Among the two, the natural and the absolute artificial, there are numerous combinations approaching with different ways according to the aesthetic, the knowledge, and the experience of a manager or constructor and the limitations they have in the constructing the infrastructure. About the landscape of Kalamaria, about 6 to 10 of the residents find it more artificial, and only 1 in 10 finds it natural. The rest of them characterize the landscape as artificial and natural imbalance. About the design of the green space of the municipality, the vast majority of the residents argued they are simple, while 15% find them too complicated. They did not answer some did not answer the questions. For the designs of the building, most residents described them as simple, while 25% of the residents described them as extremely complex. In conclusion, the municipality of Kalamaria is a beautiful seaside region in Thessaloniki. However, the residents characterize the green spaces as mediocre, while 40% of them visit them rarely, once per week or once per month. The duration of the visit lasts less than 25 minutes for most of them. According to Panagopoulos, research conducted with municipality residents visit pavements at least once a week for 40 to 60 minutes. Also, the improvement of the aesthetic of the urban landscape and the people's quality of life evaluated as important function of pavements offer. Residents usually visit parks with his or her mate or alone. About 50% choose the bench that encourages communications, and about 40% chooses benches that help to isolate themselves from other people. With applying hierarchical log linear analysis, we see the residents visit the parks more frequently for more time, evaluate the green space more positive, while the residents choose benches that help isolation, evaluate the green spaces more negatively. Through all that, we come to the conclusion that except for the necessity for better design of green spaces, to give priority to the creation of green space and isolation to the residents in order to satisfy their needs for isolation. Also, it is a point for better study of the low percentage of visitors that visit the spaces with their children or grandchildren. The degradation of ecosystems and the environment of urban development create a new tendency of creating urban installation with sustainable orientation. The design of sustainable cities plays a very important role to the improvement of the quality of the environment. Designers that meet the balance between social, financial, and environmental sustainability conclude to relevant solutions and practical compromises. Almost 6 out of 10 residents of Kalamaria perceive the landscape of their municipality as highly artificial, and the vast majority of them evaluate the design of green spaces and buildings as simple and not exaggerated. Gill says that animals and humans see the environment during movement and not only when they're stopping, but between their movements. Probably they see better during their movement. The observer who moves every day sees what their path of observation. When we go from one place to another, we have a window in front of the view and a closed window behind the view. The hidden and the obvious become one unit of environment, like we are everywhere concurrently. During the designs of the park, we have to create observation routes, not only one landscape or a figure, but a sum of thematic unities as a whole. The residents that during the design understand as important and very important that urban green constitutes an imitation of nature. Also, the infrastructure are the dominant elements of the park. There is a unity between green spaces and neighborhood buildings. Finally, the green spaces help to socialize the immigrants and refugee communities that find neutral places in them. Thank you for your attention.
Thank you very much. Do you have any questions, please? No, thank you, Mr. Tabakis, very much. We move to the next one. Actually, two. The last two presentations are from Professor Athanasios Gertsis. The first one is innovative technologies, nanobubbles and electronic water treatment to manage highly saline irrigation water in hydroponic systems. Therefore, is yours.
For your patience as well.
Thank you very much.
I need to turn on my recording that one. The first device, yes, thank you. And I also thank especially Elias for all these arrangements, sincerely. So, I push my timer, and I will try to hold it on time. We grow lettuce in floating systems. I will skip some not necessarily important slides in order to save you time, the heroic few audience that remained in this class. I present both slides, both presentations, on behalf of all the participants, students, and mainly the major contributor is PhD candidate Kostas Zoukidis, to whom me and Anastasia are supervisors. Students were involved in that, and other students, and other members. Quickly introduction. We all know the importance of lettuce. Needless to say that, that's the lovely crop of vegetarians. Salinity issue, very important. Water salinity and soil salinity. Global problem. 20% average global yield over the past few years, and increasing. That's what you need to keep in mind. It's a very detrimental factor to all plant species. Each species has a different tolerance to salinity levels. Now we'll shift in what we call nanobubbles. We are using a device that produces nanobubbles, very small size nanobubbles, which we hypothesize that if we increase the number of these nanobubbles in the water solution, remember, we grow vegetables in water solution, in floating systems. You will see the pictures next. Not in soil, not in solid substrates, like typical hydroponic substrates. Nanobubbles are very fine in order of nanomicron, 10. So this is a famous slide, very well illustrative slide from FAO, indicating the three types of soils. Normal soils, then if the salinity increases, they become saline soils, reducing productivity significantly. If salinity increases with addition of sodium chloride, then they become sodic soil. Much more difficult to correct this type of soils. Again, some figures. I will skip these figures that just represent the global magnitude of this problem. And this one also just shows the number of... Now, this is the device that was made by one of the contributors. It's an experimental yet not commercial available design. It will become commercially, hopefully soon, based on results. What was the objective of this study? Parenthesis, lettuce is very sensitive in water salinity. The sensitivity limit is somewhere between 2 and 3 decisiemens per meter. That's the unit we use to express the solubility of salts in water solutions. And so we used a range of water salinities. You will see them in the materials and methods. And also a control. Always we have to have a control. We call him tap water. It's the
And then we use regular water, but we increase the salinity of this one. So we use different varieties of lettuce and an endive variety. The research took place in the greenhouse of Perotis College. Some of these materials and methods are the same with the next slide, so I hope I don't have to say them again. We used some plastic containers, and you will see the pictures, and I think a picture is going to be worth more than what you see here. And we measure a number of parameters. So this is the containers we used, and this is the experimental design, randomized a little bit, and we grew 6 plants within each of these containers. I will skip this one. This is how we raise the salinity by dissolving sodium chloride. We took a lot of data. We were monitoring continuously important parameters of air, of water temperature and air temperature. Now, let's hit on the results immediately. And I need to make an note to the audience that only partial data are reported in most of the studies, because we want to continue on this one and probably publish it unless we are asked to be published in this conference. So, what you see here in this square, you see that the nanobubble tap water enriched with nanobubbles was consistently significantly higher in producing fresh green biomass. You see the weight of the lettuce in the last column. Now, you have to notice here something which, for us, it was surprisingly. The increase was almost proportionally to the salinity level. In other words, salinity 1, 2, 4, 6, 8, and 10, 12 was kind of difficult. It was all significantly from tap water untreated with nanobubbles. The same salinity, but not treated with nanobubbles. Fresh roots weights, that's another characteristic. Remember, the most important is the cut fresh weight. We have seen similar trend, very similar to the fresh weight. So the root weight, we took it in order to further justify maybe what happened to the above part, the green part. Remember, we don't eat roots, but roots affect what we eat, the green part. Fresh root weight, I will skip some of these other agronomic characteristics, but I have to tell you in advance that the trend was very similar, surprisingly similar. We took chlorophyll fluorescent emission, which is an indicator, sometimes, not always, of the photosynthetic efficiency. And then we have the size of nanobubbles, concentration, which I don't consider it so important for the final conclusion. And what else? What we also did, we treated the water by using 1 day, 3 days, and 7 days with nanobubbles. What we were doing, we were inserting that, it's like a filter inside the water bucket and letting it run every 1 day, 3 days, or 7 days, just to see how long these nanobubbles will last into the solution. We took an additional number of agronomic characteristics, etc., which allow me to skip them because I don't consider them so important for practical reasons. So this is how it looks from above in each of these, the plants growing in the various treatments. And let's go to the main conclusion. Let's concentrate only on the green and blue letters in this slide. So the generator, the machine, produced the best size of nanobubbles at the maximum concentration and about 10 to 12. So this is important characteristics of the machine. And it didn't matter if we ran it for 1 day or 3 days. The results were similar. This is an important conclusion to facilitate us to make it faster. Now, here is what we all need to watch out. And again, I generalize the results in terms of simplicity and in terms of application. What we have seen, very important, is that the nanobubbles
enriched treatments increased the growth and other productivity characteristics. I don't care so much about the others, but the others are supporting the growth, almost directly proportional with ECI. That was, to us, a surprising outcome. Now let's go, the tap water, however, it was the opposite. Increasing the conductivity on the regular water decreased the yield. Conclusion, we will highly recommend this device only for the hydroponic disc production system in case people are using just this system. Remember, that's not lettuce grown in soil or solid substrates. And of course, we are continuing a lot of studies. We have done previous study with this device. So we wanted to further evaluate this device. So I thank you for this. I go directly to the next presentation. I'm looking on my watch, 9 minutes, 30 seconds. Now we test 2 devices. That's another idea we had. Yes, we knew nanobubbles. We have used nanobubbles for a while, not for so long, but the next device that I will present you, we had a large experience on that for more than 10 years. So we have nanobubbles and an electronic water treatment system. Again, we use this one. Now, the important thing you need to remember from this one is salinity again. It's a huge issue all over the world. That's how it looks in Europe. That's how it looks in Greece on these 2 maps.
Around the coastlines?
Mainly around the coastline, but surprisingly enough, it is becoming a problem. It's moving upwards because of the exhaustion of irrigation water and due to overuse by pumps and, you know, the Greek irrigation system, water cannons. Anyway, yes, apparently it's obvious, more apparent, more dominant to the coastlines everywhere. So this is the device. You want to see more information and even papers, you can log in Max Grow Tech website and you can see. This device has something very interesting. It is very, let me go to this one. Let's look on the last 2 sentences. 0 maintenance. You do it, you put it in the main pipeline, you round some electrodes, you plug it in the electricity, consumes about 20 watts, less than an electricity lamp. And it handles what it does. It emits constantly low-frequency radio waves. Not only emits them constantly, but it changes the frequency 1 million times per minute. So that means there is always a radio frequency that will hit one of the molecules, calcium carbonate, magnesium carbonate, chloride, etc. So that's the little, allow me to say, secret of this device. And as I told you, we have played with this, we have tested, we have done a number of series with the older generations. So we set up very high activity, electricity ECs, salinities, up to 5. This time, we are using the latest version, generation 6. We are testing this one. Now, this is the introduction of the nanobubbles. Again, I will skip this one. We already talked a little bit about that one. I promised to finish in less than 20 minutes, and I have to keep my promise. I see Dr. Luiso is... So, that was the objective, to test both devices. One separate and then in combination. And we used 10 decisiemens. It is a very high salinity. There is no irrigation water currently from the pumps that is that high. The highest we have seen, natural irrigation, it's about 6 decisiemens. But when you do research, you need to test the limits of a system, usually. So the materials and methods, again, we used this. The concept is easier because we used controlled water versus high salinity water treated by each device separately and in combination. So we had, I don't know if you can see it, we had the little
table, we have separated this in 4 sections. The water was continuously agitated by a pump over here, and this section we installed the max grow, and in this one we were every day manually, every 3 days, increasing the nanobubbles, while we were doing this both combination of 2 devices. Let me skip again these slides, they're more or less the same. Now, let's go to the results. The results are presented by each plant species. Now, you don't see statistical difference in here. Why? Remember, endive is more tolerant to salicity than lettuce. In lettuce, we have seen statistical significant difference by the combination of the 2 devices in fresh green biomass. Remember, that's the commercial product. That's why we're interested most on that. But we have to explain why based on complementary agronomic data. I will take the fresh weight, same situation, more or less, fresh green biomass, fresh root length, again, similar, NDVI, etc. We didn't have, remember each agronomic parameter statistically is different, but the trend we need to look for is the same. Something very interesting. We assumed, we hypothesized, we didn't know, we just learned it, that the max grow device may or may not produce nanobubbles. In that case, we have to see the water. So we took water samples, treated, untreated, etc. We sent them in the collaborating laboratory in the former TI of Kavala, which now belongs to the Democritus University. So they analyzed the water and see something interesting. And this is for both crops. Don't worry on the variety. It doesn't matter. Look on the concentration. We are measuring water now, not plants. I don't know why. It might be confusing. So you see, you can see the numbers of this column here in graph and here in graph. But look at the concentration caused by the combination of this one. Look also on the size. The combination increased the concentration. The size was also increased. You have to compare it with the tap water, was increased by the max grow, and the concentration more than with the nanobubbles. So that was a very important finding. Again, pictures. Now, don't worry about this slide on the main conclusions. Let's see the next one. Actually, this one is important. I already told you the outcome was that the combination produced the more significant results. Each device produced statistical significant increase in the yield. However, the combination produced even more. That's a very important thing to remember. For me personally, since I was working with this device more than 10 years, it was very interesting to find out that one. And we were able to do that because now there is a laboratory that can analyze samples of water and measure exactly the distribution, the size, and the population, the concentration of nanobubbles. So that was for me and for us, not saying for me only, it surprises me more than the other guys because I knew the device that. So, recommendation. These 2 systems can be used safely, efficiently in hydroponic floating systems. Now, you may ask, can we use them in irrigation water, or can you? Yes, we can. Yes, but the floating system, it's much more evident because we are treating water only. We have tested the Max Grow device in field conditions, in pots condition, in soils, in substrates, etc. So I need to thank, first of all, acknowledgements to the Max Grow company and the agro company for offering us these devices. And I need to thank you, the audience, for your patience. I got 18 minutes, 19 seconds, so I kept my promise. Thank you very much, and let's have a good dinner or whatever. Thanks a lot. Thank you very much.
If you have any question, you can ask it now or during the coffee break or whatever. Any quick question? Do you have time?
Any questions? No, it's okay.
All right.
So this machine works in other crops as well, or
Yes.
only in lettuce?
Yes. No, we've tried it in other
Three
crops
crops?
as well.
3 crops?
Leafy vegetables, minimum.
Vegetables,
Yes, it works great in vineyard. It max grow now, not the nanobubbles. It works in vineyards where, you can put it on the main irrigation system of practically any crop species under the condition that the water is saline, more than 2, 3, 4. Remember, in the next 5 years, it's forecasted that the salinity will increase further. Now, and also remember that the water quality in spring is not the same as in summer. The irrigation water in summer doubles almost the electrical conductivity because of the overuse, etc. So we have to consider practical issues on that. Yes, it works. I put my signature on that. I take full responsibility of that. Thanks again,
Thank you very
and the
much
proud audience. And
for
I
the
need to thank the
interesting-
organizers and mainly that guy down there, Elias. Thanks a lot.
Thanks for the interesting presentation, the promising results. To a great, big
We
problem.
need to offer
Very big
something.
problem, yes.
That's why I was focusing on farmers. They are the audience that we address, but also students and researchers as well. My priority is the farmers. I'm sorry, guys, to say
Practical
that.
results.
You're going to be the future farmers, and you'll understand that. Why we have to give priority to 20 minutes, 22 seconds. Let's go now.
Okay, thank you very much.
Thanks a lot,
Guys, thanks a lot for your presentation here. Don't forget, 8:30, the gala dinner in the Hotel Erato. Okay? We are free to go. Thanks a lot.